Hi there, my name's Brett Hargreaves and I'm passionate about building software. Not just writing code, but building solutions. Taking a business process, identifying opportunities for streamlining and then creating an application that makes the job faster, easier, more efficient and save the business money and maybe even generate new income. Because let's face it, that's what software is all about. Making money for the developer and for the business. Even if it's personal software, it's still about making life easier and freeing up time. And as they say, time is money. But there's a problem. Too few people learn how to build software. They learn how to code. And don't get me wrong, coding is of course essential. Although there are tools that will allow you to build software without actually having to write any code. But so many people, courses and technical articles focus purely on the coding side. They miss an equally crucial part of the work, and that's the ability to structure the code and solution in such a way as to make it easy to maintain, even during the first versions. At the start, it is often considered not to be that important. As a junior developer, I would look at more complex solutions and wonder why anyone would need to build software with so many individual blocks. What does it achieve? This was primarily brought about because of how I had learned. I bought books, I watched tutorials, I read blogs, I even followed some of the official Microsoft curriculum courses, and they all taught me how to code. They all taught me how to address a particular need, an e-commerce site, maybe a social platform, in more recent times, photo sharing apps, blogging tools, all sorts of individual applications, but they all shared a common theme. They showed you how to write loops, format strings, connect to a database, or upload a file, all in the context of the app in question. As I tried to make the jump from freelance developer to professional in-house developer, I learned something new. Software houses don't like freelancers. They don't want the back bedroom self-taught tutorial-led developers. At the top end, they only want people who have already worked in big teams. Why is this? No course I could find would explain it. No blogger would detail what the problem was. But then one day I made my break and then it all became clear. And suddenly I realised what I'd been doing wrong my entire development career. You see, the problem is that I had always worked for myself, just me. I learnt from others in similar situations, self-taught bloggers, teachers reading from a book, even official material that was more bothered about teaching you how to write code. But when you become part of a team, it all changes, because now you have to work with others on the same application. As a lone developer, this is just impossible. All your code is in the same project. Your code is all mishmashed together, and trying to work on the same code base as somebody else is just unfeasible. One of the biggest reasons for software project failures, especially for freelancers, is that the code becomes too big and too unwieldy. The customer asks for one thing and you provide. But then they use your lovely new app, they realise what they asked for is not quite what they wanted, because now they've used it, now they've had a proper play with it, they understand more about what they themselves want, and so they ask the question, can you just change this? Can you just tweak that? Maybe just make this work in this way. And so you do it. Part of your ankles, the customer asked for it that way. It's not your fault if they got the requirements wrong. But how can the customer possibly know when they've never used the software before? It's one thing to imagine how it might work, but something very different when you actually start using it. This is one of the main drivers behind something called agile working practices. It states not to wait till the end to show the customer something when there might be a misunderstanding, but to constantly deliver small pieces continually, constantly, and keep getting feedback. But if you have a real big block of code and you have to keep changing it, it's going to get messy real fast. So what do? The key is modularization. You split your code into individual chunks. Each chunk is responsible for specific tasks and each chunk can be individually tested in isolation. Then we bring all these chunks together into a whole. Each bit is just a small cog in the big machine. Not only that, but you can make the cogs just the right shape, but make the actual internal workings independent to the shape. That way you can take one cog and swap it out for another. If it's the same shape, it will still fit, even though the internal workings might be different. This is absolutely fine. What we are talking about here are concepts of encapsulation and abstraction, interface segregation, single responsibility principles, dependency inversion, all terms you may have read about, but until you work on the big projects in big teams, you never really get it. But when you do, it's like a eureka moment. You suddenly realise that even on small projects, even as a lone freelance developer, these techniques make your life so much easier. You can code faster, more efficiently, you have less bugs, and therefore there's less work fixing them. Does that sound good? Let's get started. Let's install Visual Studio. The process is quite straightforward. In a browser, simply go to visualstudio.com. The page may change slightly from day to day depending on what Microsoft's advertising at that time, but generally you will see three options. We will see the Visual Studio IDE, Visual Studio Team Services, or Visual Studio Code. For our course, we're just interested in the Visual Studio IDE. If we hover over there, we then see three further editions. Again, for our purposes, the community one is absolutely fine. This is the free edition that Microsoft supply to any developer. The professional and enterprise versions are paid for versions, but the extra benefits they give you as a starter developer or even as a single freelancer, you wouldn't really need. So go ahead and click Community. This will download a very small file. We shall say let's save that. As you can see, it's come down very quickly, and we'll hit Run. When the pop-up window appears, simply click Continue, and then the installer will download a few extra bits and bobs that it needs. Now, the reason why the installer was such a small file is because rather than bring down the entire software, it just downloads the components that you need. So because of that, you will need to make sure that as you're installing it, you've got a pretty decent internet connection. So once the Bootstrap downloader has finished, we can then go and decide what sort of development we want to do. Now, as you can see, we've got lots of different options here because using the Visual Studio software, we can do lots of different kinds of development, such as mobile development, game development, extensions, and so on. For this course, the ones that we're mostly interested in is the ASP.NET and web development. That will install all the core features that you would need to get going with the course. If you wanted, a useful one would be the Azure Development Toolkit. That's not needed for this course, but if you are going to be looking at building applications for Azure, I would highly recommend that. Similar, if you think you might also want to install applications or build applications for desktop development, so for example applications that go in the Windows Store, we could include that option. And again, if we wanted, we can choose some of these. So again, if you wanted to build cross-platform applications using Xamarin, we can go for that. Mobile development with JavaScript, that's a way of creating mobile applications using JavaScript and pure HTML, or other options down here. But as I say, just for this course, the one we really need is this one here, but I'm just going to add this one here because it's just a handy one to have. Once we've got all the items that we wish, simply click the install button. As we can see here, from the options that we've selected, there's going to be around 6.5 gigabytes. So hit install, and then go and make yourself a coffee while it downloads. So once the installation's finished, you'll be brought back to the main screen, and we'll see now that we can launch it straight from here. So if we click the launch button, and this will fire up the Visual Studio IDE. The first time you start, you'll be asked to sign in. Now, you need to sign in using a Microsoft Live account. If you don't have one, simply click this link here and it will ask you to sign up. A Live account is something like a Hotmail account or an Outlook account, or you can even register a Live account against your existing email address. Whichever way, Visual Studio these days likes you to sign in because it allows you to save your settings in the cloud, and then as you go across devices you get to keep your settings with you. It also allows for easier integration with Azure and Team services. So go ahead and click the sign in button and then enter your details. And there we go. We're now ready to start using the system. What I often do now is I simply go down here to the taskbar, I right click on the icon and ask it to pin it to the taskbar. That way, as I close out of the solution, I can quickly launch it again from the taskbar there, but that's entirely your preference. But now we're ready to get started proper. I'll see you in the next lecture. Microsoft are continually updating their development tools, and the most recent incarnation of Visual Studio is Visual Studio 2019. Generally speaking, most updates are a mixture of cosmetics and enhanced tools. However, for my training courses, the differences will go largely unnoticed. In fact, I often speak to students who use a range of versions right back to Visual Studio 2008. Companies themselves rarely jump on board with new versions straight away. They'll have projects built in earlier versions or developers who just don't have time to transition. Therefore, when wondering which version you should be using, the answer is largely, it doesn't really matter. That said, people will of course start to migrate over to the latest version over time, but luckily the only real change you need to be worried about is the Create Project screen. This is the first time in over 10 years that Microsoft have actually changed this part of the process, so it's worth a quick run through what's different. My courses are all recorded using Visual Studio 2017, and so other than this Create Project screen, you won't actually see any differences. So when you launch 2019, you'll now get this new window coming up, and the first thing we usually do is create either a new project or a new solution. So the first thing we'll want is to click this Create New Project. As you can see, on the old version you used to have all your templates grouped down the left hand side. Now all the grouping happens along the top here. So for example, we can go in and select which language we want to use. We can select the platform, so for example if we're writing for Windows or Xbox, Azure and so on. Or we can have project tabs, again Cloud, Console, so on and so forth. So the first thing we normally do, or in my course that I normally do, is create an empty solution. So for that we'd go into the project type and other. Again, this is pretty much very similar to what we do in the old version, and we see here we've got the blank solution, so we simply click that and next, and again we just go through the normal process of giving it a name and where to create it. From there, the next things we would normally do is go and start to add projects to the solution. Again, we get the new project come up, and the main ones that I normally use are either class libraries or web applications. Now we need to be careful because obviously a lot of defaults now are using .NET Core or .NET Standard. Again, it doesn't really matter what you're using, but as I tend to focus more on .NET 4.7, we just need to make sure we use the original framework versions. So for example, if we're creating a website, we would say project and web, By default, the top one is ASP.NET Core Web Application, but actually in a lot of my courses I want this ASP.NET Web Application .NET Framework, and it's this that you need to look for when you're writing applications that need to be backwardsly compatible. So again, we'll click Next. Again, we'll give it a name. And again, just as before, we select the templates that we'll do. Again, it's slightly different, but all the information looks pretty much the same. So we'll want either MVC or Web API, depending on which courseware you're taking. And then you click Create. And that will go ahead and create the project as normal. The other common project we normally create is a library project. Again, we'll go to Add New Project. So to find the library project, again, we go to Project Type, and we actually have library project type there. And again, it comes up with the different versions that we can use. And again, for most of mine, we will usually want the .NET framework. But again, depending on which course you're taking, we might be using the .NET Core or the .NET Standard. Either way, select the one we want, ensuring you've got the correct framework. Click Next. Again, give it a name, and then click Create. Once all that's done, you will find the rest of what we use the same as normal. So when you're managing NuGet packages or using any of the IntelliSense tools, they'll all look exactly the same. Most applications need to be able to store information in some way, and the most common way of doing that is within a database. In the Microsoft world, this is quite commonly using Microsoft SQL Server. And Microsoft make available a number of editions specifically for developers. The easiest way to get the most recent version is to go to microsoft.com/SQL Server, which will then take you to the SQL Server platform that's the latest edition at that time. What we want to do is go to the Downloads page and then select the edition we want. There are three options. The first is we could have a full-blown version of SQL Server, but that's limited to 180 days. As a developer, we could go for a Developer Edition SQL Server. This is a fully featured edition and is licensed specifically for use in test and development, so while you're building applications and especially learning, it can be ideal. The other version is SQL 2016 Express. The Express version, again, is a full-blown product and can be used in production environments. The difference is, because it's Express, you're limited to the database size. Previously, this database size used to be around 2 GB, but from 2016, they've upped that to 10 GB. Generally speaking, I would go for the Express edition. So once we've downloaded the X file, it's usually a small file because it downloads the main binaries when we run it. We then just hit Run. We then choose which option we want to go for. If you're going to want to install this a number of times, it's sometimes a very good idea to download the actual media file. For now, I'm just going to go with the basic edition. Accept the license terms and install. Once the download and basic installation is finished, you'll be brought to this screen here. These are quite important. The instance name and instance ID explains to us how we will configure our connection strings when we connect to our database. And in fact, it's quite a handy idea to copy this string here because this will be used within our applications later on in the course when we start looking at databases. So if you want to, hit that, which will copy it to the clipboard, and then we could save that off to our desktop for future reference. So that's now installed the SQL Server service. However, it hasn't given us any way to actually interact with that service. So what we need to do is go and install what's called the SQL Server Management Studio. And actually there's a link to it right down here. This will now take us to the SQL Server Management Studio download page, again to download the latest version. If you've not installed SQL before, we can just go ahead and hit the main download link. Again, save that to disk. Once that's finished downloading, let's just run it. And click the install button. Once that's finished, it may want to restart, so just go ahead and hit restart. As soon as it's rebooted, we should be good to go. Again, like with Visual Studio, I often like to put shortcuts on my desktop here. So if we go into the search bar and type SSMS for SQL Server Management Studio to launch the app, when it starts up by default it will try to connect or ask you to connect to the local instance that it's just installed. It's helpful just to click connect to make sure we've connected and just have a scan to make sure we can see at least the system databases. So now we know that's all installed fine, we can right click on our icon down here and pin it to the taskbar. And that's done. SQL Studio Server is now ready to go. Hi there, and welcome to this section, which is a C# primer. Now, ASP.NET MVC websites are built kind of in two sections. We have the front end, which is where you have all your HTML, CSS and JavaScript, which is generally considered the client-side UI. And then we have what's called the back end, which is really what we're talking about when we talk about MVC websites, because it's how we structure this back end that dynamically creates our pages and sends them to the client. And this back end is written either in C# or VB.NET. And as this course is about C#, we'll be looking at the C# programming language. Because we're going to be using C#, what we need to do is learn how C# itself works and how we write programs using C#. Therefore, this section really is for you newbies out there who've never really done any programming or at least have never used C# before. In this section, we'll be looking at how we build a simple C# program, and from that we will then look at the structure of what makes up a general C# program. From there we'll start to build on that, and we'll introduce variables and types, we'll look at collections and arrays, we'll look at how we manage program flow and make decisions within an application using statements and operators. And then finally we'll look at how we can debug a program as we go through. So join us on our first lesson when we'll look at how to build a very simple C# program. Hi there, and welcome to the first lecture where we actually start to write some code. First, we're just going to build a very basic Hello World console program. We won't be doing anything too fancy, and the whole process should only take a couple of minutes. I'm also not going to go through any real detail, we'll do that in the subsequent chapters. For now, let's just go ahead and start creating something. Launch Visual Studio if you've not done so already, and then go to the File menu, New, and choose Project. This brings up a dialog that brings up a series of templates. So these templates are predefined scaffolding for applications that help us out with what's sometimes known as boilerplate code. We're just going to choose a very simple one. Down this left hand side here, make sure we're looking in Visual C#, make sure we've highlighted Windows Classic Desktop, and then over in the main bit click the Console app. By default, it will store it in Documents, Visual Studio Projects, and we're just going to give it a name. We'll call it Hello World. Click OK, and an empty project is scaffolded out for us. As I say, we'll go through this in more detail in subsequent lectures, but for now I'd like to move your cursor just underneath here, just to the right of this first brace, this little squiggle here underneath where it says static void, and press enter to create a new line. We're now going to write console full stop on the keyboard and right line. Now you'll notice as I started typing it, it brings up these drop downs that are helpers to make sure we're writing things as we should be. This is known as IntelliSense, and again we'll be using it quite a lot through these lectures. For now we just want right line, and now we want an opening parenthesis or bracket. We then want a couple of quotation marks, and then we're going to type in Hello World between those quotation marks, and finally at the very end we're going to have a semicolon. We're going to write another command now. Again we'll do console. This time we will say read line. Again we will have opening and closing parentheses but nothing else in between them, but again we'll have a semicolon. Hopefully your screen will look like this. So what we're going to do now is actually launch our program. At the top of the screen here we've got this start button by a green triangle. So this will launch the program in what's called debug mode. Hit that and hopefully it will launch a window and print out our Hello World text. So as you can see, we've now got a fully functioning and working program. Well done. Make sure this window is highlighted and simply press enter. You might have to press it twice, and that will close down the program. And that's it. That's how simple it is to write software. In the next lecture, we'll start walking through what all this actually does and some of the more intricate parts of it. In this lecture, we'll have a look at the structure of our program. First of all, let's have a look at the files that make up our program in the Solution Explorer. So over to the right hand side, we'll see here our Solution Explorer. Let's just expand that. And first of all, you'll see we have this solution and it's called Hello World. Whenever you create a new project in Visual Studio, it also creates a solution, and by default, the solution name is the same as the project. And in that solution, we then have the project itself. In our case, this is called Hello World. The reason for this is that you can actually have multiple projects in any one solution. However, in our case, we currently only have one. In this example, we created a project and the solution was automatically generated. As you build more complex projects, you would actually create the solution itself separately and then add each project manually. Within the project, we have this Properties node, a References node, and this app.config, and finally this program.cs. So in this Properties node, we have this assemblyinfo.cs. This file contains some information about our project, and if we open it up, we can see here. And it has things such as an assembly title. We can put in things like an assembly description, configuration, and so on and so forth. You can edit this file directly in here if you wanted to change any of this information, or alternatively, right-click the project itself and go to Properties. And this brings up a lot of the same information, and if we click this assembly information, here we have a lot of the same information and things that we can set that we saw in our actual file. If we just cancel out of that for now and then just close that tab down and that. So next we have this references node. This contains links to other assemblies or class libraries. Class libraries are compiled bits of software that has been written by someone else, and it's through here that we can see what are the software our project relies upon or depends upon. Before software you write is run, it has to be compiled. Compiling means converting our scripted C# language into something a bit closer to binary that computers understand. As part of the compilation process, any reference files are linked to yours, basic syntax checking takes place, and then the compiled program files are copied into a bin folder. When we click start to run our program earlier, it actually compiled the software for us and then ran the compiled .exe file that was generated. If you want to see that file, if we right click the Hello World project and then say Open Folder in File Explorer, so this opens up our project, and here we can see there is this bin folder. So if we have a look in there, then we have debug. So at the moment we've been running in debug. You can also run in something called a release mode, which would create a release folder here. For now, let's go into the debug folder, and we can see here our Hello World exe file application itself, a configuration file, and a debug file. The references in here are actually part of Windows itself. Sometimes when you add references, they come from external libraries, and in these cases, those files themselves, those compiled bits of software, will get built and compiled into what's called a DLL or a dynamic linked library, and in those instances, those would also get copied into your bin folder. Now let's have a look at our app.config file. This file is an XML file, which is basically like HTML, that we can use to store application configuration. Often when you add external libraries to your project, this file can be updated with relevant information. You can also define your own app settings in here. So for example, we could store information that our app will use, but that we could change easily without needing to recompile. So for example, if your application was to send an email to yourself any time something happened, rather than hard code that within the code itself, you could set it in this configuration file. And then whenever you needed to update who was emailed, you could update that configuration file rather than having to rebuild and redeploy the entire application. Finally, we have the program.cs file. This is where we wrote our code. And as you can see, at the top, we have this series of using statements followed by some names. Note that some of these names are the same as what we see in here in this references. So for example, we've got using system. We've got using collections, link, text and threading, and all these are also part of this system library. This system library is the core library that C# uses, and the others derive from this library or other libraries specified in the references of the project. This naming, or these names, are what are called namespaces. A namespace is like a full address to a usable bit of code. Rather like your address is your address where you live wouldn't just be 10 or 100 or England. Rather, it will be something such as 10 Baker Street, London, England. These namespaces are the full address to the code we want. They are also hierarchical, again, just like street addresses. We'll go into namespaces in more detail when we look at object-oriented programming, but for now, you need to know that if you want to use some code from another library, so for example, code from within the system library, you need to have made sure that you add it as a reference. As an example, the console command that we used here came from system, and as we hover over, we can see that it's telling us where it comes from, system.console. If we were to take out this using statement, and we can do that rather than deleting it, we can comment it out by having 2 forward slashes in front of it. You'll see now that this has an issue, we get a red squiggle underneath it saying there's a problem, and it's no longer appearing in blue. And as we hover over, we see an error saying the name console does not exist in the current context. We can fix that by clicking this little light bulb here, and it will give us options for what we can do to fix it. So the first would be to have using system, which is what we had before. The other way we can use it is to reference it fully within our code itself, which would be this option here. So if I left click on there, so now it fills it in and it's valid again. So rather than having the using statements at the top, you could simply write out the entire line for the code for each command that you needed. But obviously, when you're using it a lot, it's usually much easier to have the using statements. Let's get back to our code itself. So after our using statements, we have this namespace here, this namespace keyword, and just as we spoke about namespace for these, all software you write has to be contained within its own namespace. By default, the first namespace it uses is based on your project name, so in this case it's called our namespace hello. Next we have this brace, or this squiggly vertical line. All code and sections of code must be bound in opening and closing braces. This helps tell Visual Studio the correct scope for any section. Next we have this class statement, followed by our program name, which in this case is program. This also forms part of the namespace. So for example, the full namespace of program is hello world.program. Again, we'll look at classes in more detail later, but for now remember that all code must reside within a class, and all classes must reside within a namespace. Next we have what's called a method. In this case, our method is static void. This method also has an input parameter, which is a set of strings which we can refer to as args. We know that they are parameters because we are in these brackets here. So every method must have brackets which will define some input. You don't always need to have input, but you do always need the brackets. So a method is a bit of code within a class that can be called by an external class. In the case of our program, the main method is automatically called and any argument sent in when we hit run. Once compiled, because it's a console program, it could be run from a DOS command, which means we would be able to run the program and then pass in a series of strings which will be captured by these string args. Later on, we'll have further methods that return more information, such as text and numbers. However, this one doesn't return anything, hence why it is void, void meaning to return nothing. Because this is a Windows application, Windows always knows to call this main program. Like the namespace and the class, the code in the method is encapsulated within braces, and again, this defines the scope of our code within the method. So our first command line is using the console external program, or console external class, which as we saw earlier was part of system. And when we type console and then hit a plus, a dot or a period, we see a number of methods and properties that this program actually exposes. And in this case, we use the WriteLine method. So just as we have our main method here, this console program exposes this WriteLine method. Similarly, just as our method allows us, we have defined some arguments that can be sent in when called, the WriteLine method also allows us to send in some text, and in this case we've sent in the string hello world. When calling methods of a program, you must always call them with these brackets, even if we're not actually going to be sending any statements in. So for example, if we were to simply type WriteLine and put a semicolon, which means it's the end of the line, you'll see that we've got an error, and actually we can see the error here saying that we cannot this object cannot be used as a statement, and the fix for that would simply be to put empty curly brackets. So in this instance we are actually not sending anything through, but we still need to have those brackets. The final line we have is readline. Because writeline is only outputting, you can see as we hover over it, it says void console.writeline, and just like our static void main, that void means this won't actually return anything. However, if we hover over readline, readline is saying it will return a string. This means that when you type anything into the console, and you can then capture it using this readline statement and send it back. Again, readline isn't taking any parameters, but we still need to include the bracket because it's a method. So that's a brief rundown of the structure of a C# program. In the next lecture, we'll start going a bit more in depth and start to look at variables. Hi, welcome back. In this lecture we're going to talk about variables. If you think about any program, what it basically does is manipulate and move information around. Think about the Hello World program. We've used two methods of the console class, writeline and readline. As mentioned in the previous lecture, writeline takes in a parameter, and we knew this because when we type the writeline and open our first parenthesis, it tells us that it's expecting in a value of some kind. To show a better example of how writeline is built, let's create our own method within our class. So this method is very similar to the method that's built in console. And let's just have a look at what we've built. So this bit here is known as the method signature, and it defines a number of things, and the structure is always the same. For now, ignore the fact that we're using static, because that is just a special kind of way of defining classes which we'll cover later on. Every method signature follows this same pattern. We define the return type. So in this case, we're returning void, i.e. we're not actually returning anything. Next is the method name, in this case we have writeline. And then finally we have input parameters. We can have no input parameters. We can have one input parameter, or we can have as many input parameters as we want. However, if you define an input parameter, then you have to include it when calling that method. The returning input parameters are variables, and as the name implies, a variable can vary in its data. A variable is essentially an area of computer memory set aside to store the value, and throughout the process of your program you may want to write and read from that variable. In our program we've actually hard-coded a string of hello world. However, in the real life you'd probably want to store that in a variable, because that variable may want to be input by a user, you might want to have read it from a configuration file. There's lots of different options. The point is, you would rarely want to hard code a particular string. Internally, this writeline method itself never actually uses a string literal. Internally, it acts on a variable. And then when we call the method and pass in this string, it's acting on that variable, such as outputting it to screen. It's a lot like algebra. In algebra, you would have a plus b equals c. The idea being that a or b could be anything you wanted, but c would always be the result of those two numbers. Let's get some better examples of how this works by building our own variables. Before we use a variable, we must declare it. And it's important to understand where we declare a variable. If we declare a variable within a method, that variable is only accessible within that method. However, if we declare a variable higher up within the class itself and outside an existing methods, then those variables can be accessed by anywhere in our program. To keep things simple, we're just going to declare some variables within our main method. We declare a variable by telling it what the variable type is first of all. So in this case, we're going to create a string, and then we're going to give it a handle. So a handle is just some way we can refer to that variable in later code. So now we have our variable, we can then use this handle to assign a value to it by saying equals and then passing in a value. So in this case, we are saying put a value into that variable. Note we use the quotation marks around the actual string. This is something you must always do with strings, much like how we used quotation marks around the hello world in the writeLine method. We can also actually assign a variable when we declare the string. So for example, within the declaration itself, we could have an assignment. We can also assign the value of one string to another. So now we could say another value equals my value, and so now both strings have the same value in them. To see this in action, let's actually see what happens when we assign strings and reassign them. So we'll keep with these two strings, but this time we'll put different data in each one. So we've declared two variables of type string, and in one we've put the data value1, in the other we've put the data value2. Now let's replace our writeLine here, and rather than outputting hello world, instead we're going to send in our variable. We'll do the same again, and we will output another value. And then what we're going to do is we're going to reassign the data in another value to be the same as what's in my value. So what this should do is take the data that's stored in this variable and then put it into there. And again, we'll print that off just to make sure that's working. So now let's run our program and see what happens. So as you can see, first of all we've output my value, which was value1. Then we've output another value, which was value2. But then we've assigned the data that was in my value to another value and then printed out another value. And as you can see, it has now been updated to what was in the original variable. So far we've only used text variables, but of course there are many different kinds. So in the next lecture, let's have a look at some of the more common variables and how they are used. Hi, welcome back. In this lecture we're going to look at different variable types. So in the previous lecture we looked at using string variables, and strings are great for storing all sorts of information, but they're not always the best type to use. One example of why we can't just use strings all the time comes down to how the system allows you to interact with the type and how much memory the type uses. For example, if we tried to add two strings together, it would simply concatenate those two strings. So if we had my value equals my value plus another value, it would simply add these two strings together. Even if we replaced these with pure numbers within the strings, it would simply print out 1 and 2 rather than actually adding them together. And that's because strings are always considered string literals. So if we wanted to do arithmetic, then we would start to have to use different variable types. There are quite a lot of different variable types available, but in this lecture we're just going to look at some of the more common ones. We declare other variable types in exactly the same way as we have done here. So let's create two new ones. We're going to create two integers. So an integer is a whole number, and we will have number 1 equals 1. And let's create another one, 2 equals 2. The usual rules apply. We can assign a value at declaration time, although sometimes you don't always need to, and you can assign variables of the same type to each other. So for example, we could just as easily say number 2 equals number 1. So in this case it is taking the data that is in the number 1 variable and putting it in number 2. And that is only possible because both of these variables are of the same type. So for example, let's have a look at another type. Let's have a look at something called a Boolean. So Booleans are basically true or false. And they're the only two types we can store within a Boolean. Now if we try to assign the value of that Boolean to our number, you'll see that we get an error, and the error is saying cannot implicitly convert bool to int. Another factor to consider is how we can manipulate these types. So as we said earlier, imagine that we wanted to add two numbers together. Modify your program. Let's have the value of 1 assigned to number 1 and the value 5 assigned to number 2. Remove this line here. We don't want to have them the same as each other. And in our first write line, let's output number 1 plus number 2. While we're at it, on the second write line, let's add my value plus another value. So in the first, we're using the same operator in both methods, but in the first we're adding together two integers, and in the second we're adding together two values, two string values. Let's just remove these lines of code, and now let's run the program. So as you can see, in the first instance where it's adding two numbers, it's performed an arithmetic operation, so 5 add 1 equals 6, but in the second instance, because they are string literals, it has just concatenated the two strings together, so 1 followed by a 2 becomes 12. Sometimes you do need to convert between one type and another. Depending on what you're trying to convert between will determine what options you have. First, let's take a common and basic example. If you have two numbers, say a equals 5 and b equals 5, and you actually want to concatenate them as strings, then you would need to convert them to strings first. So as we saw here, we have 1 and 5, and if we try to add them together, it would perform a numerical operation on them. What we can do instead is we can convert them to strings. So after the number, we can do a full stop, and we have this method with any number which is toString, and we need to put our parentheses in because it's a method, and again the string on here. So in this example, we're actually converting our numbers to strings, and then we're adding them together. So let's see what happens now. So as you can see, rather than having 1 add 5, it's now just concatenated them because it's dealing with them as strings. It's also possible to go the other way around, for example to convert a string to a number, but unfortunately it's not quite as straightforward. If we want to change a string to an int, we have to use a special function called a convert function. And we can use the convert function in itself in two ways. First of all, we can use something called the convert class. And the convert class is convert full stop, and then you tell it what you want to convert a string to. So for example, we could convert it to an int32, and then we can pass in a string. Another way is to use the parse extension of a particular value type. So for example, instead of convert to int32, we could say int32.parse, and again pass in our number. With either of these options, we do have an intrinsic problem. That being is, if we were to pass in an invalid value, for example, if we tried to pass in 1, then we're not getting an error at design time. The compiler thinks that's perfectly valid. However, if we were to try to run this program, we'd actually get a runtime error. See what I mean? Let's try running our program now with our int32 parse with 1 in text. So straight away the debugger pauses and highlights the line that's causing us a problem and tells us input string was not in the correct format, i.e. it doesn't know how to parse 1 like that. If we hit the stop button up here, that will prematurely stop us debugging the program and take us back to our code. The same error will occur for any kind of conversion. So unless you're absolutely sure someone can't enter a silly value, for example, you could use a drop-down box to limit options to what a user might send through, then we need to find another way to make sure that a piece of software doesn't break if somebody puts something in wrong. And the way we can do that is, instead of using parse, we can use try parse. Now try parse in itself doesn't work in the normal way. So for example, both parse and int32 actually return the value that we're trying to convert to. So for example, if we have int converted, so in both these cases, what we're actually doing is putting the value of the converted number into this integer. However, the try parse actually returns a Boolean value because the try parse actually tells us whether an operation was successful. Therefore, when we're doing a try parse, what we actually have to do is add what we're passing the number to, the variable where we want to store it, as a parameter. And in the case of a try parse, we actually have to add this extra command in, which is out. So in this example, this would still fail. However, if we run it, even though it's failed, it's not crashed the program, because all it's done, it's failed trying to parse it and therefore carried on execution. Okay, let's put some of this into action and write something a little bit more meaningful and sort of a little bit real world. Let's just get rid of everything we've done so far and start again. So first let's declare a couple of numbers. So the first thing we'll do is we're going to write some text to the console that says enter a number. Next, we're going to store into a new variable the result of the readline command. So if you remember from earlier, readLine actually returns a string because it allows the user to input a value. It will then store that value and send it back. So in this case, we're going to store the returned number in this variable called snum. Copy and paste that line because we will ask them to add another number. And now we're going to try to convert whatever number we send in into an integer so that we can perform some arithmetic process on it. Let's just do, for a bit more consistency, we'll change that to snum1. Oops. So let's walk through the code we've written. So we've declared 3 integer variables and we've assigned a value of 0 to them. Next, we're going to write out to the console asking the user to enter a number, and then when the user enters a number and presses return, it will store the value of what they enter into snum. It will do the same again for another value. It will then try to convert those return strings into numbers, into integers. It will then add the 2 numbers together as integers, so perform an arithmetic operation on them, and then it will print out the result of that answer. So let's see what happens now. So it's asking us to enter a number, so we can enter, say, 5, then enter a number 10, and then it's added the 2 numbers together and output them. Let's try it again. However, this time we're going to use text. Now what happens is the answer is 0 because in both cases it's not been able to parse the strings into numbers. Therefore it is just defaulted to the numbers we assigned to them originally, which was 0. Hopefully that program makes sense and you get an idea of how different variables can be used in different ways. Hi and welcome back. Sometimes it would be useful if we could define our own complex types, and we can use this using either structs or classes. The two options appear to work in the same way, however there are very big differences in how we manage them. To start, let's imagine we want to store information about a pet. If we just wanted to store a pet's name or type, we could just use a string. But what if we wanted to store both of these things and others, but all grouped together within the same type? So for this, we can use our classes or structs, and then we can create methods and properties that relate to what we want to store. Classes and structs need to be defined outside of another class, and as our program is a class, it means we have to write the code outside the class program, but within the namespace braces. We'll examine both classes and structs at the same time. In your program, clear out everything in the main and we'll start to build up from scratch. So the first, we'll create our classes and then we'll create a struct. As you can see, they're done in very much the same way and very similar to our class definition here. The only difference is here we've used the class keyword and here we've used a struct keyword. Next, within them, we're going to define some public variables that will be able to be accessed within those classes or structs. In our struct, it's almost exactly the same, so in fact we can just copy and paste the code. So as you can see, other than the fact that we've used class or struct keywords to define our types, there is no difference. However, also note this public keyword in front of our property definitions. Don't worry about this for now, we will cover it in a later lecture. For this example, just make sure you include the public in front of our variable definitions. Now to use them, we must declare the variables within our main method as normal. So for example, enter the following code. First create a pet struct, which we will call a dog, and then have a pet class, which will be a duck. For each one, we can then go and start to declare values or store values in the underlying properties, and we do this similar to how we use the console.writeLine, whereas writeLine was a method we access using the full stop or period. To access a underlying variable of a class or a struct is very much the same. We simply select the underlying variable and then just use the equal sign as though it was a normal variable. Next, for each one, we're going to output to the console some information about each of our classes. So if we try to run this, we'd actually get an error, and in fact notice this red squiggle under duck.type. This is Visual Studio telling us that we'll get an error. Hover over the squiggle and with the mouse and we will see this box pop up which says use of unassigned variable duck. So what's going on? Well, this is the first example of the differences between a struct and a class. Because a struct is just a structure of our definition, it's what's known as a value type, and one consequence of this is that we can declare it just like any other type. But a class is what's known as a reference type, and all classes must first be instantiated before they can be used. How do we instantiate a class? We use the new keyword. One of the main reasons for this is that classes can have what's called a constructor, A constructor allows us to set up properties if we want when we instantiate them. We're going to look at classes in much greater detail in later lectures, especially in the section on object-oriented programming. But for now, just change our code to look like this. So all we've done is added the new keyword, and then we've said it is a new pet class. And again, just like we do with method, we've added these parentheses. Now the error disappears, and in fact we can now run the program. Actually, let's just add in a readline. And that will pause execution before we've actually interacted. So a dog has 4 legs, a duck has 2. If we just, the reason why I didn't do that on a new line is because we used right rather than right line. Again. Okay. So as you can see, we've assigned them in pretty much the same way, except for the slight difference with the new keyword for a class, but the output has worked in pretty much the same way. Now let's say we only wanted people to be able to create pet types of dog or duck. What we can do is, rather than have this type property as a string, we can set it as another type of user-defined type called an enum. An enum is a type we define ourselves, but rather than defining properties and methods like what we have just done, we instead define a list of available values that a user can choose. Underneath our class and struct, create a new section, and this time we will say enum, and we will call it pet type. Again, we need the braces, but instead of declaring variables, we're simply going to have dog and duck. Now if we change our type within our class and pet struct to pet type, we'll see that now in our definitions we're getting an error because it's no longer a string. So what we do is we'll replace the string, and all we do is we reference our pet type enum, do a full stop, and then it brings up one of the two options that we defined within the pet type. So in this case we have dog, and in this case we have duck. So as you can see, that's a great way if you want to constrict the options you can select. When we were talking about the differences between classes and structs, I mentioned that a class was a reference type and a struct was a value type. This has quite far-reaching implications for your code, so we'll consider this in the next lecture. Hi there. In the last lecture I mentioned that classes are reference types and structs are value types. Integers, strings, bools and all the other built-in types are also value types, and there's an important distinction between the two that we need to point out at this stage. With a value type, if you pass a variable into another method, then the value is copied. This means any actions performed on that variable are only applied to that copy, and if you want a result back, you need to explicitly return it and assign it back to your original variable. With reference types, you pass in a reference to the original variable, often known as objects when dealing with classes, and therefore any actions performed apply to the original object. If at this point you have a blank expression on your face, don't worry about it, we'll explain it better with an example. In our program class, let's create a new method called multiply legs. This method will take in a pet struct and a pet class. And what we're going to do is with each one we're going to multiply the number of legs. So in our pet struct, we're going to say the number of legs is the number of legs multiplied by 2, and then we're going to do exactly the same on the pet class that we send in. So as you can see, we are passing in a pet struct and then we're passing in a pet class, and on each of them we are changing the underlying legs variable to be multiplied by 2. We will then just send out the results to the console so that we can see what's actually happening. So we're going to say that this is being written from the internal method. We're going to tell it what the type was, and we're going to tell it what the value of the number of legs was. And let's do the same for the pet class. So with our method written, we're now going to use that method from within our main program. We're going to have to make a slight change to the pet dog, how we're declaring it, and we basically need to tell it to use a new keyword just like we did with class. And this is because we want to pass the object around. When working with structs internally, we don't need to use the new keyword, but if we're wanting to pass it to another method, then we do need to use the new keyword. But again, it looks very, very similar. Well, it looks exactly the same to how we use a class. Next, after the line where we're writing to the console how many legs each animal have, we're going to call the multiply legs method, and we're going to send in our pet struct and our pet class. And then we're going to write out again the number of legs. So before we run it, let's just step through what's going to happen. We're creating our struct and our class, and then we're printing out the number of legs that each has. So in the case of the dog, it will come out at 4, the duck will come out at 2. We're then running the multiply legs method by passing in our struct and our class. That method itself will print out the number of legs, and then we're going to print them out again from outside the method. So let's run this and see what happens. The first two right lines are as we'd expect. A dog has 4 legs, a dog has 2. We're then multiplying the number of legs. So on the pet struct, a dog has 4 legs, multiplied by 2 becomes 8. So that is correct. Again, on the internal method, a duck starts with 2 and multiplied by 2 becomes 4. However, when we come back outside of the method, the dog is back to having 4 legs, but the duck still has 4 legs from the multiplication that we ran on it. And this is because when we sent the dog variable into the method ends up working on a copy of that dog variable rather than the original one, whereas the duck being a reference type, the calculation is applied to the original object that we're sending in. This is a very important and common gotcha, because as well as this happening during passing objects around, it can also happen when we manually copy them. So as you can see, although classes and structs appear at first to be the same, they can be handled very differently, and as you go through development you'll start to encounter situations where you'll find that one is definitely better than the other. Often you will want to store data in lists, either lists of numbers, lists of strings, or even lists of objects. C# provides a number of ways to achieve this, and in this lecture we'll examine a couple. The most basic way of storing data in a list is using an array. An array is simply a collection of data. The advantage of arrays is that they are fast and memory efficient. However, the downside is that they are not particularly flexible or easy to use from a programmatic point of view. The most basic kind of array is known as a single dimensional array, and we can use it to store a single column. When declaring an array, you need to tell it the type of information it will store, for example strings, integers, booleans and so on. And we declare arrays in a very similar way to how we declare normal variables. So for example, if we wanted an array of integers, we would use int, but we would then put 2 square brackets, and this tells the compiler that actually we're declaring an array. We then define the name, and then we need to use the new keyword to tell the compiler to initialize the array. And when we initialize the array, we also define how many items we're going to put in the array. Similarly, to define a string array, we would do the same again. And again, we would tell it how many items we would be storing in the array. We can also populate the arrays as we create them. When we do that, we then don't need to tell it how many items we'll be storing. We simply pass in the items we wish to store. In this instance, we just have the opening and closing square brackets, and then we use curly braces to define the values that we want to store in the array. Similar again with a string. And so on. Arrays are also known as what is zero indexed. This means that the first position in an array is actually position 0, the second is position 1, and so on. Therefore, when we want to set the value or retrieve the values of an array, you need to bear this in mind. So for example, if we take our integer array, if we wanted to put the number 5 as the first item in the list, we would use int array. We would define the position, So position 1 is 0, and then we tell it what we want to store. Again, if we wanted to store it in position 2, we'd use 1, 3 would use 2, and so on. Getting the data back out is exactly the same. So we would say if we wanted to get the data back out of the array, we could say array 0, and that will pull the data out of there into that variable. So this is storing data as a single column. You can also create something called multidimensional arrays. Multidimensional arrays allow us to store two groups of data, and we can simply double up on the brackets when we're defining them. So for example, to define a multidimensional integer array, again we use the square brackets, but this time we need to put a comma in. And now when we tell our array how many items we're going to put in it, we need to tell it how many items we're going to place in each column. So in this example, we're telling it there's going to be 2 items in the first column and 3 items in the second. Again, we can initialize our arrays when we define them. So when we're initializing a multi-dimensional array, it's slightly different. The start is the same. However, this time we don't define new int, we just go ahead and define our lists of numbers that we want to insert. Also, each list of numbers or each column needs to be within its own parentheses, within its own curly braces, within a master set of curly braces. So for example, we could have 1, 2, 3, 4, 5, 6, 7. We reference each particular number that we want by defining which column and which row we would want to access. If we got the value from 0, 0, this would get us the value from the first row and the first column, which in this case would be 1. Or if we went 1, 2, this would give us the value of the second set of numbers and the third number in that second set. So in this case the value would be 7. As you can see, there's a lot you can do with multi-dimensional arrays, and they can get quite complicated. The main limitation with arrays is that once you're declared, you can't add more values than you've initially asked for. So if you declare an array with a length of 5 and you need to add a 6th element, you basically need to create a new array and copy your elements into it and then add the new item. Of course, you could always just define one huge great big array and hope you don't exceed the length, but then you're using memory unnecessarily. Neither can you sort arrays. If you wanted to sort the data in an array, you would have to programmatically build this logic for yourself by looping through each value, comparing it to the previous one, and then swapping them based on what should be in the order that you want. This is often called a bubble sort, whereby the highest value eventually bubbles to the top. But the point is, it's something you have to take control of yourself. As an alternative to arrays, we can use a number of different kinds of collections that C# exposes to us. And collections provide a lot of the functionality for us that we would normally have to write ourselves within arrays. underneath them they actually do use arrays, but all that complexity is handled for us. The most common kind of collection you'll probably come across is the list. You'll often see a list referred to as list T. T is basically a reference type and means that we can define our own when we initialize it. So, for example, if we wanted a list of strings, we would say list string, and because lists are reference types, we have to, i.e. like classes, we have to initialize them with the new keyword, and again we just say list string, and then we use open and close parentheses to finish it off. Once we have a list, we don't need to define how many items are in it. We can simply go ahead and start adding items. Each subsequent add to the method simply adds a new value to the end of the list. We can also insert items within an existing list by using the insert. So if we were to say add here, that would add a string as a second item within the list. However, if we said insert and stated the index to be 0, that would insert the item to the top of the list. As you can see, lists, because they're based underlying on arrays, are also 0-based indexed. Removing items from arrays is just as easy. We can either specify the item we're removing. So if we wanted to remove a specific string, we would simply enter that, remove. Alternatively, we can remove an item by specifying the 0-based index of the item that we want to remove. When using an index, we would use remove at rather than remove. Finally, as we mentioned, one of the complex things we would have to handle ourselves with arrays is performing a sort. With arrays, it's very easy. We would simply say list dot sort, and that will automatically sort our list for us by inferring the type that we have sent in. Again, just like an array, we access or set data or override data within a list using an index-based notation. So for example, this command would return the first item in our list. Very similar to list, we have also a dictionary. Note again, the way in which we refer to it would be dictionary T key, T value. Dictionaries allow us to define a collection of keys and values. In other words, rather than just specifying the index of our data, we can give it a key that can then be used to find the data at a later date. And just like the list, the data we store can be pretty much anything we want. As an example, let's say we wanted to store a collection of first and last names. We could do it like this. So we would, when defining it, again we will define what the two items are going to be. So the key would be a string and the value would be a string. And again, because it is basically a reference type, we would use the new keyword to instantiate it. And again, just as with lists, we simply use the add keyword. And pass in the two values that we want to add. Now, instead of referencing using the zero-based index, what we can actually do is reference it via the key or the string that we've entered for the key. So in the above example, we would reference it rather than zero base, we would actually pass through the actual key that we have defined. Again, just like strings, to remove an item, we can simply reference the key of the item we want to remove. Because of the ways dictionaries work, the concept of an index or a sort method is kind of irrelevant, and therefore we simply have sort methods and remove methods. When dealing with collections, you will often be called upon to use something called LINQ. And LINQ is a query language that can be used to find elements within lists. Dictionaries enable us to find items based on the key. But sometimes you want to return either a subset of a list based on a certain filter, or because we can also store objects in a list, for example, we could store a list of pet class, we need a way to search for a particular pet based on a particular property of that pet class object. LINQ enables us to do just this, and there are actually two ways in which we can write LINQ queries, either as a query or a method. A LINQ query takes the form list some object that we are wanting to list, for example, pet class. Then we give the query result a handle that we can refer to. And then we use a LINQ syntax such as from. Then we create an inline variable, which is just a very fast way of creating a variable that we can reference within the scope of our query. So X can be anything we want. Then we say in the list of items that we are querying. Then we would say where X dot and then the item that we want to query on equals and the item or the value that we want to look for, and then we would say select X. So of course it's much easier to show an example if we're doing an actual list. Therefore what we will do is we will create a new list of pet classes, which will call it pets. And we will now add some pets. So when we say add, there's two ways we can add items. We can either create a new pet, so pet class and then add that variable, or there's a quicker way whereby we can say new pet class and then we use curly braces, so it's very similar to when we were defining and initializing our arrays. We can go ahead and create a class, our object in line. So once we've done our curly brackets, when we then press space, we start to get all the values we want to add. So we could say, then we separate the different items with a comma, and as you can see, as we start to build up, it removes the items from the list because we've already used them. So again, we could then just copy this line and add a second pet. So now we have a list, we can query it using the LINQ query syntax we just saw. So we would define a new list to store our results. And we would say from P in pets. As I say, P can be anything, it's just a variable we will use to refer to it within the confines of the LINQ query. Then we would say where P dot type equals pet type dot dog. And then finally we would say select P. Now because this is going to return an array, we then just enclose our entire query in brackets, and then we have to call a toList method which converts the resulting query back into a new list. Once we have our new list, we can start to use it as normal. So for example, we could say found results dot count would print out to our console the number of items in the results set. So let's just step through that again. We've created a list of pet class and added 2 pets. Then we've added 2 pets to that list. We've then created a new list of pets called results. And in those results we've passed the output of the LINQ query, which is here. Also, don't forget, because of how we're writing this, we need these brackets. And then because the actual result of a LINQ query is a query result rather than a list, we call a toList method, which then returns it as a list. Then finally, when we've called the count, it just returns the number of items in the results list. If rather than returning the results to the list as a list, what we can instead do is get the first item in a list. So we could instead just say pet class results, and instead of toList we can say first or default. So this will return a single item, and this would often be used if you're looking for example, a particular item within a list. So for example, if we were searching for where the name equals Pluto. Note that when we're doing a comparer, so when we're trying to find all items where a particular variable is equal to something, we have to use a double equal sign. So I said there's actually 2 ways we can perform queries. So the first was using a LINQ statement. The second is that you can use something called a lambda query. So a lambda query uses LINQ methods which take in a lambda expression. So if we revert this to what it used to be, this same query could be written in this way. So results, because we're going to reuse this result set, we start by declaring or referencing our underlying collection itself, and then we use the where keyword. Again, we need to get a handle on a variable within the collection to use. So what we do this time is we would do P, we would do equals greater than P. So this is saying we're declaring an inline variable or a variable just within the scope of this query called P. and what we want to do is find all items where the type equals pet type dog, and once again we need to return that as a list. So both these queries are exactly the same. As you can see, that's a little bit shorter-hand, however they can get a little bit more complex. Again, to return a single item, rather than where, we could say first or default. However, again, the syntax or the lambda query we put inside is exactly the same. So that one would return a single item. Which of those two methods you use is entirely up to you. For shorter, simpler queries, the lambda querying tends to be easier. However, for more complex result sets, especially if you want to query across related lists, then the full LINQ query expressions do tend to be that bit easier. In any application, you're going to want to control the way the program flows. What we mean by this is that no program simply runs through a series of statements and stops. At some point, you will want to execute a specific set of code depending on a particular outcome of something. For example, a program might ask you for your age, and depending on what value you put may send the program off down a different route. We may also wish to reiterate over a list of steps until some condition is met. There are a number of ways we can control the flow of a program. So over the next few chapters, we're going to cover a few concepts. The first is we're going to cover comparing values. Then we're going to look at one of the first decision trees we can use, which is an if-then-else statement. We'll then look at loops and the various loops we can use to iterate over actions. And then finally we'll look at another kind of comparison called switches. So in order to achieve any kind of decision making in a program, we need to be able to compare two values. For example, we might want to ask if a user has typed in or selected a specific number or text. We might want to loop through a series of steps a set number of times or until a precondition has been met. Whatever it is, ultimately, it all comes down to comparing a value for a certain result. Let's look at this following statement. In order to compare two strings, we use a double equals sign. So in this example, we've got a string equals another string. This will return either a true result or a false result. If the contents of a string contains the same contents as another string, it will return true. If the contents are not the same, then it will return false. When dealing with strings, you need to be careful because any comparison has to be exact in order for them to return true, and this includes spaces and case. So for example, if the a string is all in uppercase but another string is all in lowercase, but still the same letters, it would still return false. So you just need to make sure that when you are comparing strings, everything is exact. There is another way we can compare two strings, and that is almost the opposite of a double equals, and this is an exclamation equals or a not equals. So this is, as I say, the complete opposite. So if the contents of a string does not equal the contents of another string, then it would return true. Conversely, if a string did equal the contents of another string, the result would be false. So think of it as turning it on its head. The same works with integers and dates. If we wanted to compare two numbers, we would simply have a double equal sign, and again, if we wanted to compare dates, we would again use the double equal sign. Again, the not value applies. So if you wanted to check if two values are not the same, we would use again the exclamation equals, and in this case 10 exclamation equals 20 would return true because 10 doesn't equal 20. When dealing with integers, we also have a few other options, and that is checking if a number is less than or greater than. So in these two examples, we've got is 10 less than or equal to 20, and is 10 greater than or equal to 20. Dependent on the outcome, we'll return true or false. So now we know how to compare values, let's have a look at one of the most common occurrences in a program flow, which is to check the value, and depending on what that value is, we might want to execute one area of code or another. The standard syntax is if condition, then you would do the code that you have specified, else perform the other code. So for example, if the condition was does 10 equals 10, then you would say if 10 equals 10, and then you would write the code in the next block of code, and then if the opposite was true and 10 did not equal 10, it would execute the code in the else statement. Another way of controlling program flow is with loops. Again, a popular kind of loop is called a while loop, and similarly, a while loop uses a condition. So while a condition is true, then it would keep looping through. So a typical example is you would check on a Boolean value, so you would maybe have a variable that you would set initially to true, and then you would loop through, and dependent on the code that you've written, at some point once you've achieved some sort of success, you will maybe then set that to false, so that would cause the while loop to finish. Another kind of loop is a for loop. Looping until a set condition is met is all very good, but sometimes you'd have an infinite loop, and sometimes we just want to set the loop to go around a set number of times. So in this case we would use a for loop, and we simply set a starting number. We say what a number condition would be, so for example we would set that a starting number had to be less than 10 or 20 or 100, and then we tell the code how many increments for the number to increase in. The standard would be just to increase 1 after each loop. Sometimes you may want to go up 10, 20 or more. Finally, we have something called a switch statement. A switch statement is a little bit like an if statement, but rather than having lots of ifs, we can simply say for a given value, check the case where the value compares, and then execute the code in the relevant case statement. So that was a brief overview of the different ways you can control the flow of the program. Over the next few lectures, we'll actually see them in practice. We're going to start building a very simple guessing game using some of the conditional statements we briefly looked at. I'm going to do this using a new project. So go to File, New Project. Again, this is going to be a console app, and I'm just going to call it Program Flow. The first thing we're going to need is to set up some basic variables. So because this is a number guessing game, first of all we're going to define what the number actually is that the user needs to guess, and we'll store that in a variable called our number, and we'll just give it a value, let's say 10. We're then going to ask the user via the console to actually input a guess. We're going to store the answer by using the console read line. And then we're going to have to parse the result that they've given us, because obviously it will come back as a string, and we're going to parse it to an integer. So what we're doing here, as I say, is asking the user to enter a number, and then using the read line we're storing that answer and converting it into a string. So what we want to do is compare the guess that the user has entered with our number, and if they match we say well done, and if it doesn't match then we tell them that we've got it wrong. So to do that we're just going to use a very simple straightforward if statement. So we're going to say if the guess number is equal to our number, we're simply going to print out well done. We then have an else statement which will get executed if the guess number does not equal our number. And then finally, as we did before, we're just going to ask the user to press any key to finish the program. As you can see, a very simple, straightforward program, so let's just run that and see what happens. So first of all, let's guess the number wrong, so we'll put 20, and then it tells us it's wrong. Now let's run the program again, but this time we'll answer it correctly. We know of course the answer is 10, and then it executes the code where the two numbers are the same. A slightly modified version of if-else is to use something called an else-if. This set of statements allows us to have more than just two choices. So for example, rather than just saying right or wrong, we might want to say if they were lower or higher. So let's update our code slightly. So first of all, if they guess the number correctly, again we will say it's correct. However, what we want to do now is compare to see whether the actual guess was higher or lower. So we will change this else statement to, put an extra statement in here, and we'll have else space if and a new code block. And again, after the if, we can have another value check. So this time we can say, was the guess number greater than our number? And if it was, we can tell them that they were too high. So if that was false, it would go through to this statement. And if that was false, we actually know that the number must have been lower than the guess number. So in which case, again, let's just update what we're telling the user to tell them that actually their guess was too low. So let's now run the program and see what happens now. First of all, let's guess too high. And now let's run the program again, and this time we'll guess too low. By mixing if-elses and else-ifs, we can get some fairly rudimentary but powerful program flow. You've probably noticed that there's a fairly major flaw with our number guessing game so far. That being, as soon as you've entered a guess, it quits the program. Of course, what we want to do is ask for input more than once. What we could do is simply copy and paste our code, constantly asking for a guess and comparing the result. But how many guesses do you want to give? 5, 10, 100? We really don't want to keep copying our code for as many times as we might need. However, in cases like this, where you want to go round and round until a condition is met, i.e. we've guessed the right answer, a while loop seems to fit a little better. A while loop keeps going round the same bit of code again and again until the precondition is met. The danger is that you need to ensure the condition might eventually be met, otherwise the code would just loop infinitely. So what we need to do is move our question code, the bit that asks for the number, into another method which we can then call from our main method. This stops us from having to rewrite the same bit of code after each permutation. We can then have a while loop that checks if the answer matches the number, and if not, it keeps going round. So create a new method up here called getGuess. We're going to set a result that the user will return, and we're going to copy and paste this code here. So this is the bit of the code that's simply asking the user to guess a number, gets the answer and then parses it. Just need to update that to be result, and then we'll return that result. Get rid of this guess number. So now we have that. Again, we just need to define our guess number back down here. And rather than having this line of code in our main, instead we will say guess number equals get guess. Next, we're going to create a while loop. Now, because this is still valid, every time the user enters a guess, we need to check to see if it was correct, greater than or lower than. But what we want to do is wrap that inside a loop. And what we're going to do is we're going to say while, and we tell it what condition needs to return true in order for the loop to keep going. So we want it to keep going round while our number does not equal the guess number. So while our number does not equal the guess number. So as long as they keep putting the wrong answer in, we want to keep looping round. So let's save that and run the program again. So let's go too low. Oops, something's gone wrong there. So the reason why that was infinite looping is because we've put this in the wrong place here. Our actual get guess needs to be within the loop, because otherwise we're never going to get an updated guess. So let's just try that again. Guess too low, guess too high, and now guess just right. And now it will allow us to quit the program. Looping until a set condition is met is again very good, but sometimes you'd rather have a finite loop, i.e. a loop that is only a set number of steps. So again, let's modify our code again slightly. First of all, rather than creating a new project and deleting our existing code, we'll just comment out this code here. So I'm going to highlight it all, and I'm just going to press this button up here, which is comment out selected lines, and that just takes it out. Now we're going to put in a different type of loop, and this is going to be a for loop. And what we're going to do is we're going to say we want to have a number that will be a starting number, so we will say an int n, and we give it a starting value, which is 20. So now we can refer to n throughout the code and throughout the loop. We're going to say keep looping while n is greater than 0. So we're saying create a variable called n, set its initial value to 20, and keep looping while that n is greater than 0. And then we're going to tell it after every iteration round the loop, we're going to decrease n by 1. So we could either put n equals n minus 1, which will decrease it by 1 each time, or we can have this minus minus, which does the same thing. Now let's put our code block in there, so that will loop through. Oops, that needs to be n minus minus. So again, what we can do now is we can just copy and paste this code. And just uncomment those blocks. And we're going to modify the statement slightly just to tell the user how many guesses they have left. So what we're doing is we're using this syntax here whereby we can put within our text these curly brackets with a 0 in, and that tells us that after the comma of our right line statement we can then pass in a value. We're doing n minus 1 because as each loop goes round we actually need to tell the user how many loops we've got left. Again, let's just copy and paste that into this one down here. And save it, and then run the code. Again, just put some values in, and as you can see, each time we put a value in, it's telling us how many guesses we've got left, and it will keep going through like that until we until we've run out of guesses. So even though we got the answer correct, then we're still going to keep going through because we've told it to keep going through a set number of times. And finally, when we've no guesses left, it allows us to quit. So let's just walk through this again. First we have this for keyword and the brackets, and then we give it the conditions. It needs 3 conditions: a variable that we will check, what condition that variable must meet in order to keep going, and an action to apply to that variable at the end of each iteration. So in this example, we've declared and set the number n with an initial value of 20. We then tell it to keep going while n is greater than 0, and then we tell it to keep decreasing n by 1. And then we just keep iterating through our code before, spitting out the results. As we saw in that example we've just run through, even though we got the answer correct, it still kept looping through. So let's quickly fix that. If you want to prematurely break out of a loop, we simply use the break keyword. So if the user enters the correct number, simply add break into that option there, and that will prematurely exit the loop for us. So let's just try it again with that slight modification in place. And now when we enter the correct, it allows us to quit the program. So as you can see, 2 very powerful ways of iterating over conditions: while loops and for loops, and the one you use will often depend on what you're trying to do with your code. The final flow mechanism is called a switch loop. A switch loop is a bit like an if-then-else loop, except it's a much neater way of handling multiple options. Let's imagine we want to add a special message if the user entered the value 1, 2, 3, 4 or 5, and then the usual messages if they enter any other number. We could have multiple if-then-elses. If num equals 1, else if num equals 2, else if num equals 3, and so on and so forth. But a far simpler method is to use a switch statement. The way it works is that you give the variable you want to compare against the value and then use case statements followed by each permutation. You then write the code you wish to execute against that permutation. The code will keep passing down the options, executing the code against every option that matches. So if a value could match multiple case statements and you wanted to stop after hitting the first one, you again have to exit the loop prematurely with the break statement like we did with our for loop. It also means that you need to be aware of the order in which you enter the case statements. And then finally you have a default case which is executed last if none of the others have been hit. The compare in the case statement must be a constant. It can't be a variable. In our code, the number we store our actual number in is a variable. So the first thing we need to do is make it into what's known as a constant. A constant is like a variable, except for the fact that once it's declared, you can't change it. So first of all, we need to change this our number from a variable to a constant. And to do that, we simply put const in front of the declaration like that. Next, let's write our switch statement. What we will do is we'll keep our for loop that goes round up to 20 times. We're going to use our getGuess function to ask the user what the number they're guessing. However, this time we're going to remove these if then else statements and replace it with a switch. So we use switch guess number, which is the value of what we want to compare, and then we set certain cases. So the first case we want to check against is the guess number equal to our number? And if it is, we say, actually we will just copy this. After your case statement, you need a colon, not a semicolon. Then we set the loop to 0. So this, by setting the end to 0, that will prematurely break out of our loop for us. And then we say break. Now the break statement here will only break out of the switch, which is why we have to set the loop variable to 0, as that will cause it to finish. And then we can put our other case statements in. So let's now have a case if the number they guess is 1. Then let's have it write something else. Again, we need a break statement to tell it to exit the switch loop. Let's have another case of the user entering the value 20. And finally, let's have another case where the user enters 100 to tell them that was way too high. And then finally we have our default statement. So in this point we use the keyword default. So this is basically saying if none of these get hit, then we run the following code. And what we will now do is we will copy our if then else loop down here, and comment that, and then again break out once it's finished that code, and that's our switch. So let's have a brief walk through this. We're going to iterate through the loop up to 20 times, and each time we're going to ask the number to guess what the number is. We're going to then compare that guessed number with various results using our case statements. So in the case that the guessed number is the same as our number, then we can tell them it was correct and exit out. We're then going to say if they entered the number 1, we'll print out this message. If 20, they'll print out this. 100, they'll print out this. Let's just update that actually. And failing all else, we're simply going to run the code here. Actually, what we don't want to do is, that will never be correct, so we don't need it, so we'll just change that slightly. And then save that, and now let's run our game again. So first we'll enter 1, now 20, 100, and then just any other value, before finally issuing our correct guess, and it quits the program. As you can see, again, switch statements when combined with everything else give you a great deal of power. Do be warned though, the more complex your logic gets, the harder it can be to debug. And if you do have complex logic, you should consider splitting the code up into more manageable sections. The Visual Studio software does a very good job of picking up lots of errors as you're programming, by placing red squiggles under anything that is blatantly wrong. Maybe you've tried to read a variable that hasn't declared yet, or perhaps you've mistyped a variable or statement. And maybe even you've tried to call a function and sent it the wrong kind of variable, a string instead of an int. When you compile, the compiler will capture even more for you and prompt you as to where and why it is wrong. But even then there are things that will be missed, simply because either the compiler couldn't detect the issue until you ran the program, or your logic's a bit skewed somewhere, which is often known as a bug. A little bit of trivia for you. Why is a software error called a bug? Once upon a time, the very first computers didn't have microelectronics. Can you imagine that? And so they were built using mechanical valves. Just like today's computers, however, these mechanical ones worked on the principle of binary numbers, ones and zeros. When a valve was open, it represented 0, and when it was closed, it represented 1. By configuring the valves in specific patterns, the first computer programs were written. However, these machines were huge, and I mean really huge. They'd have to be being built from valves, and sometimes they got a glitch in the system, and what caused these glitches were actual insects such as spiders and beetles getting into the valves and stopping them working properly. Hence, the computer literally had bugs in it. The term bug and the act of cleaning it, debugging, has stayed with the computer industry ever since. So to clean our code, we debug it. Debugging is where you walk through your code a step at a time trying to find out why the errors are occurring. You'll use the debugger throughout this course to see just what happens to your code as you work through and try to fix things when they go wrong. But for this lecture, we'll have a look at the basics of how we do that. You've already come across the debugger in action. Whenever you press Start button to launch the software, it starts by default in debug mode. This is why on occasions, if we had errors, the debugger automatically halts and takes you to the error. When we were looking at variables, we tried to convert the text 1 into an int 32 and it threw an error. The error box that came up provided us information about the error. It tries to suggest what the error may have caused it and even suggest tips on what to do to fix it. So straight away we knew not only what the offending line of code was, but a pretty good idea of what was wrong. Let's put this into practice. We're going to use this number guessing game that we created, and in the guess number method we actually perform a try parse where it tries to output the number. Because we used a try parse, if we actually entered in something that wasn't a number, it would have just gracefully carried on because it would have assumed it was just a 0. So we actually want to properly break this. So we're going to change this try parse into a parse. So we're going to parse the answer and we're going to put the result into the result variable. So what's going to happen now is if we enter some text instead of a number, it will actually break. With this in place, let's run our program to see what I mean. So rather than put an actual number in, let's put in some text. As you can see, we get an error come up. It's halted at the line of code and highlighted it in green and told us what it is. The input string was not the correct format. In other words, it couldn't convert it to an integer. So what would be handy to know is what was actually passed in. And if we actually hover over our variable, their answer, it actually tells us the value of what the user has passed in. So we can see from this screen that we entered 2 in letters rather than an actual number, which obviously isn't what we need and why the program crashed. Also note down here, we see even more information in this locals window. Again, we can see the answer variable has the text 2 in it and our result has a 0 in it. This is a very powerful way of knowing when things go wrong. Sometimes your code might be in production when it fails and so you can't exactly do this. And in addition, sometimes code will fail because it didn't behave as we expected, but the actual program itself didn't crash. As an example, revert the int32 parse line back to what we had originally. So stop the program, and what we can do is quickly we can press Ctrl Z to just undo our lines of code. So let's start our program again. Now if we put in some string text, it simply carries on going round because, as we said, it's assumed 0. The point is, the program still runs fine without crashing out because the try parse just skipped over that conversion. Operationally, however, something did go wrong because the user didn't really enter a valid response. In our number guess, so this is hardly drastic, but in a real-life system, quite often, if a user inputs the wrong kind of data, it might cause issues further down the line. For example, the system may have just stored the data in a database, and then when some other process tries to perform a calculation on that data, it fails because we've allowed the wrong input to be entered. So what we will do now, in order to debug a user complaint, so for example, they've run a help desk and said, I keep entering an answer and it never gets it right, no matter what I put. We want to create what's called a breakpoint in our code so we can simulate what the user's doing and see what's happening in the actual program. Stop our program, and what we're going to do is create a breakpoint. So down the left hand side you see this grey bar, and if we click on it at a particular line, so for example if we move down to our for loop and we press the left button in the grey bar, it puts a red circle there along our line. So this is what's known as a breakpoint, and what will happen when we run, it will run through the code, but as soon as it hits this line it will simply stop. So let's run our code again. So straight away, before we've got any errors or anything, it's just stopped us where it told us to stop. And now we're in the running code, and again if we look in our locals box at the bottom, we can see the variables that are currently in scope. So for example, we can see that n is at 0 and the hour number variable is at 10. Guess number is not in this box because we're not yet in the block of code that would bring it into scope. However, if we hover our mouse over the guess number within the code, we can see that it is actually at 0 anyway. Next we want to step through our code line by line, so we can either press the F11 key on our keyboard, or we can go up to the top menu here and press this button here, and as you can see it's helping us tell us that another shortcut again is F11. So if we press that, or press F11 and keep pressing it, it will gradually take us through our code. Again, let's keep pressing until we get to the read line. So now it takes us back to our console for us to input something. And again, the code will carry on, and again we can carry on debugging through it. But now as we're stepping through, again we can check to see what's actually happening to our variables in the code itself. If we want to stop manually going through the code a line at a time, we simply hit continue, and then we can carry on going through. If we want to remove our breakpoint, all we do is go back over to it within our code, click the left button again against it, and it removes it. At this most basic level, using the debugger is very simple, and the majority of your debugging will be done following these very simple steps. Another really handy use for the debugger is understanding someone else's code. At some point you will either inherit or copy some of the developer's code, and sometimes trying to figure out what that code does can be very difficult depending on the complexity of the task that it is running. That said, if a program is written well, it should in theory be easy to follow, but unfortunately that is not always the case. By using the debugger to step through someone else's code, we get a much better insight of what it's doing and how it does it. Welcome to the section on Object-Oriented Programming. Object-Oriented Programming, or OOP as it is sometimes referred to, is about breaking down your code into objects. An object usually represents a thing that has some properties or maybe some methods. In Microsoft.NET, an object is synonymous with a class. In other words, when you create an object, you would create a class. Because of this, classes and objects are often used interchangeably within the context of Microsoft.NET applications and in Visual Studio. A property of an object is usually a bit of data, for example, a person's name or a product sale amount. Methods are actions that may affect the data of that object in some way. For example, an account action might have a payment method that decreases the balance property. The idea is that everything in software is essentially just a collection of things that all interact with each other. Sometimes these things are representations of real-world objects, for example, customer, product or account. If your program in your program, if a customer buys a product, it can cause the account object to change, i.e. the outstanding balance might increase. Sometimes these things are more abstract representations of functionality. So for example, you might have a stock manager object, and this is responsible for acting on various other objects, for example, reducing the stock level of another object when certain other actions occur on them. Objects also have or implement certain characteristics. The main ones are encapsulation, polymorphism, and inheritance. Encapsulation is about ensuring an object groups together all the necessary properties and methods for that object. For example, a customer object might have a name and address field that relates to that particular customer, and you shouldn't need to query other objects or services. However, objects can contain other objects. So for example, you might have an address object that defines street, town and postcode, and the customer may have a property of address. In this way, the customer is known as a root object and the address is known as a leaf object. Inheritance is the ability of objects to extend other objects by gaining all the original object's base properties and then adding their own. For example, you might have a person base class and then a customer and supplier subclass that inherit from person. In this way, common properties and methods, for example an address and a name, can be built into the person base class, and specific properties and methods that only relate to the new type of object are only written to the new object. Therefore, the resultant object contains all the properties and methods of the base object and all the new methods and properties of your new object. Polymorphism is where two objects can have the same properties and methods but implement them differently internally. This is often achieved through the use of an interface. The interface would define the properties and methods, sometimes known as the signatures, and then each object would implement that interface accordingly. An example might be a simple calculator program. You would have a result object that has a single method called compute, and that returns a number. The method will take in two inputs as numbers and then do something with them. For example, one version of the object might add the two together, another implementation of the object might subtract the numbers. Each of these different objects would implement an iResult interface, which basically says I'm going to return a number as an output and take in two numbers as inputs, and as long as the objects implement those methods and properties as defined, we can swap them in and out as we need. Let's run through some more examples of how and why we might use objects. Let's say in our application we're building an e-commerce site. As part of that, we're going to want to store and record product information. We're going to want to store and record customer information. Hopefully customers are going to be adding things to a basket, and then at the end of it we're going to be taking those products out of the basket and creating an order with them. Now somehow you need to get products into the basket when people add them to the basket, and so what we would then do is create another object called a basket service, and this basket service would be responsible for facilitating that. Similarly, once a user wants to actually place the order, we would have an order service that would take all the products out of the basket and put them into an order object. Finally, we might have an account base object, and then we would have customer and supplier objects. Because both customer and supplier both implement a lot of the same methods and properties, we would inherit them and implement the account object. So that's the theory of object-oriented programming. Let's now get into actually showing some real-world examples by creating a very basic program. So let's actually create some objects or classes. Start Visual Studio and create a new project. Make sure we're in Visual C#, Windows Desktop, and then choose the console application. We're just going to call it Playground. Okay. So it's created us a very basic project here. We've got a class called Program and we've got a single method. Don't worry too much about that at the moment. What we want to do is create our own class so that we can examine how it's made up. So the first thing we're going to do is we say class, because we're creating a class. We need to give it a name, so we shall call it my object, and then we need these brackets. So within the context of our object, we can define properties and methods. So first of all, let's call a property. So we'll have a string property, and we will call it my string property. Again, we have the open and close bracket, and in here we define what are called getters and setters. The most basic we can have is get and set. And what this allows us to do is simply assign a string value to that property or get a string value from that property. The other thing we might want is a method. Now a method might return a value or it might not. If it doesn't return a value, we start with void and then we give it a name. and then we do a normal brackets, and in here we can define whether it's going to receive any input. So for example, we could send a string in, or we could send a string and an integer in, and then within the actual method itself we can do something with those. So if we then have our curly brackets, we're now within the body of the method itself, and as you can see we can now access these parameters that we are sending in, and the IntelliSense is bringing it up with us because it tells us we can access them. If we were to take these out, it's not appearing because it's no longer a valid property. Similarly, a method might actually want to return a value. For example, it might want to return a string. Again, you'll see now that we've got an error, and that's because it's expecting something within the construct of this method to return something. To make it return something, we simply use the return keyword. So for example, return, and that's going to make it return a string, call some value. To actually start using that object, if we go up to our main program, what we're going to do is use something, a command called console, that allows us to output something to the screen. So what we're going to do, first of all, we're just going to have console.readline, open and close brackets because it's actually a method that doesn't receive anything, and press return. Now all that's going to do, it's going to sit there and wait for the user to type something in. So let's just start it to see exactly what's going to happen. Click start, and as you can see, it simply gives us a blank command line, and when we press enter, it finishes the program. I'm just going to zoom this in so we can see things a bit better. So now we've got that. What we want to do, obviously there's no point reading anything if it's not displaying any data, so what we want to do is we want to output some text to that console box. So what we're going to do, we're going to create an instance of my object. So what we need to do is we need to say my object. So we are basically defining a variable that is based on my object. This is similar to if you were to type string, some string, equals some value, but instead of using string we're using our own object, and we need to say, give it a name for the variable, then we need to say equals new my object, and open and close the brackets. So what this is doing, it's creating an instance of a my object class. We're calling it my object. We'll notice we've used lowercase because Visual Studio is case sensitive, so these are actually two different things, and this is fairly common programming practices when you do this. And then we say new class of my object, and then we have the open curly brackets. Now the reason why they're empty is because in our class itself we don't have something called a constructor. We'll come to that in a minute. So what we can now do is use this object. The first thing I forgot to do is, if we try to use this object at the moment, so if we type my object and then put dot, you'll see that we can't actually access any of these properties, and that's because we've not declared them as public. So what we need to do is make both this method and this property public. So now when we go up to the my object and press full stop, we can now see the my string property and the my method. So what we will do is we will say console.writeLine. So this is going to output something, and it wants text. If we click this little arrow here, we can see the different things, the different inputs or different parameters that it's expecting in, and one of those will be string. So we can say my object dot my method, and again we need the open and close brackets with nothing in because our actual method doesn't take anything there. then when we run that, as you can see, we're outputting the my value that's come from our object. Press any key and it will quit the program. So let's do something a bit more complex here. Let's have instead of a string property, let's have two integers. And what we shall also have is a method that returns an integer. We'll call it calculate. Now what we're going to do is we're going to return number 1 plus number 2. So now within our object we can set these numbers. Oops, number 1 equals 10. Number 2 equals 5. And in our right line we shall simply say number 1 is, so this is passing in some straight text, and then we're going to add to that my object, and we're just going to reference the actual properties. So these aren't doing any calculations, these are just the base properties. So let's just copy that a couple of times, and we shall change that to number 2, and then we shall say the calculation is, and now we're going to call the calculate method. So as you can see, we're assigning numbers to these two properties, and then we're calling the calculate method that's going to add the two numbers together. And as you can see, number 1 is 10, number 2 is 5, and the calculation is the calculation itself. Now rather than have to manually input these numbers into these variables here, instead what we might have is, in our calculate method we might want to take the inputs. So instead of doing that, let's remove these. We'll just comment them out. That's going to break these. So we'll just comment them out. And this time we're going to take inputs within here. So in input int number 1 and int number 2. Now in our calculate method we want to physically just send in the numbers. So rather than assign them to internal properties within the object, we're just assigning them to as parameters within the method. And again, when we run that, it just outputs the result. So that's the basics of classes. Let's have a look at a few more things you can do with them and how they work internally. Let's say we want these two properties, and then we want a third property called number 3. Now sometimes the properties themselves that you expose aren't necessarily always going to contain just the information you want. Sometimes they might want to contain other information. The easiest way to explain that is, instead of having this calculate class, we could have this number 3 perform the calculation. So what we would need to do is we could declare internal variables, a common method for doing this would be to have an underscore. So for example, underscore number 1. This isn't any technical reason why you have to do this, it's just more a common way of doing things. And because it's internal, we don't need a getter and a setter methods, we'll just define them. So let's define 2. Oops. What we will do now is when we define these number 1s and 2s, rather than just store them intrinsically within this property itself, what we will do, we shall redirect them to the internal property instead. So on our get method, we shall return the value of our internal number, and on our set method we shall set number 1 equal to value. Let's do the same for number 2, except it's going to return 1 and 2. Now the way we have it at the moment, there is no difference with these two numbers what we have done there than when we had it set like that. It's basically doing exactly the same thing, except it's storing the numbers themselves within an internal variable. And these numbers 1, 2, 3, as we mentioned earlier, because they're not set as public, we can't actually access them, only the public properties. But what we might want to do is, on number 3, we might not want a setter method at all. We might just always want to return the calculation. So in this case we return number 1 plus number 2. So this is effectively doing the same thing as the calculate method, but now instead of being a method, it's actually a property. It's just that we're, instead of just returning the value of whatever we've set it to, we can actually perform calculations. So once again, in here, let's set these numbers again, except here we're going to say and we're just going to reference the property. So now if we run that, we're getting the exact same thing. This way of having separate internal variables to store our public variables can be quite handy when we start using something called constructors. When we call our object up here, as you can see, we've not included anything in these brackets, and that's because the object itself doesn't need to take anything in. For example, our calculate method takes in 2 numbers, but our class itself, doesn't actually need to take any numbers, but sometimes you might want to. So for example, when we create our base object class, we might want to set some predefined numbers in there when we actually create the object. So what we do is we create what's called a constructor, and the way we do that is we create a public my object, so we're calling it the same as our actual class, and we're going to tell it to take in a couple of numbers, and we're going to assign them. So number 1, the internal number 1, equals our number 1 that we are passing in, and same for our number 2. Actually, it's getting yes, that's correct. So if we were to run this now, you'll see that it's not working, because now the my object is expecting to take in 2 numbers. So what we now have to do is send in, and because we're putting them in there, we no longer need to manually set them there. So as you can see, it's a bit of a shorter-handed way we can construct our object and predefine base values when we create the object. And as you will see, we're getting the same result. Now sometimes you might not want to add numbers, or you might do. So what we can do is we can call what's called overloaded methods and constructors. So for example, we could have another constructor here that simply does nothing. And now when we define the object, we can simply omit those, and because there are two constructors of my object, one that takes two numbers and one that doesn't take any numbers, it just knows to use this constructor here. So for example, instead we could still perform some logic in here. We could set them to some base values of our own choosing. So now we can say my object 1, we will create it with no values. Let's create another instance of the object called my object 2, but this time we're going to pass in 10 and 10. Let's just copy this line. And then run that. So as you can see, the first object that we passed no parameters into, it's taken our default constructor, and the second object where we've used what's known the overloaded constructor, it's taken the 10 numbers in, and so use those instead. Finally, just as we had two different constructors, we can do the same on methods themselves. So for example, we can have public int calculate, which again returns the same value, but again, because it's not taking any parameters in, it's going to use the default values rather than the numbers we're passing in. Actually, we'll just need to use the internal numbers there. So again, on our object, oops, we can run calculate with nothing, so you can see there, or if we click the down arrow here, we can see or it wants to take number 1 and number 2. So as I say, that is known as operator overloading, and it's just very handy to do when you have the same method or the same object with multiple constructors to be handled in different ways. In the example we've been working through, our new objects, our new classes, have all been within the context or the same file as our main program. In the real world, this would rarely happen. Apart from anything else, if you had all your classes within the same project file, you would end up with one huge, great big project file, and it would be very, very difficult to navigate. So what generally you do is, for each class, you would create a class file of its own. So what we shall do is we will move our myObject class and we'll move it into its own file. So within the Playground project, if we right click and we say add, and we can choose class. From our list that comes up, class is at the top, so we can simply overwrite it and let's call it myObject. So this creates by default a new class called myObject. If we simply take this code and cut it all out and then we shall paste it in over the top. So now we've moved that entire class into a file of its own. Now you will see that the code still works exactly as before. As you can see, and that's because it is linked, because it's within the bounds of the same project, and something called the namespace is the same, which we'll go into later. It just knows that it's there. So it's just a way of breaking up our project and maintaining coherence. Now sometimes you want to actually have your objects in a completely separate project. Now the reason why you might want to do that is because you might want to write a series of classes that can be reused, so other applications may want to use them. Or perhaps you want to be able to break up the workload into individual maintainable projects. For example, many people might be working on a very large solution, and so you'll break the solution down into individual projects. Each bit of the project is responsible for its own functionality, and then the whole get brought in at a later date. So let's examine this a bit further. So instead of right clicking our project, Playground, we're going to right click our solution, and we're going to say add, and we're going to say new project. The other way we could do it is if we just went to the file menu and said new project. It does the same thing. The important thing is that the solution needs to be added to the solution. The project needs to be added to the solution as opposed to creating a new solution, and that will create it in our overall solution. So this one we're going to call My Library. And what we're also going to do is, for the project type, we're going to call it a class library. So again, what we shall do is we shall go into My Object, and we shall copy all that into there. And what we shall also do, when you create a new project, it creates a basic class of its own. So we'll just rename that to what we want it to be, which is My Object. The alternative way is, what generally people do is they delete that starter class and just create a new one. It doesn't really matter which way you do it. We'll save that, and then we'll delete the My Object file from there. In theory, we could have just copied that class straight in, but I'll explain in a minute why we didn't. For now, let's just go back to our main program, and oops, it can no longer find the My Object class. Why is this? Well, now it's in a completely different project. It's in the main solution, but it's still in a different project, which means it's no idea where the My Object is. Now what we could do is, if we go to My Object, you will notice that the namespace is My Library. So the namespace is the name of our project. Similarly, in the Playground project, the namespace is Playground. Now, namespaces are about being able to manage code that are in different libraries without them causing conflicts with each other. What do I mean by this? Well, first of all, one way we could fix this is we could change the namespace to Playground, and then what we can do within the Playground project, if we right click Preferences and click right click References and click Add Reference, we have this option to choose Solution, and as you can see, the My Library project appears here. So we'll simply select that and say OK. Now what's that doing? Well, what's that is doing is it's telling the the playground project that it wants to reference this project here. We'll go into a bit more detail, but for now, if you want to reference another project within the solution, that's how you link the two together. So what we need to do now is if we compile, so if we do a build, and one final change we need to make to my object is, just as we made the methods and properties public here, we need to make the class itself public now because it's a different solution. Again, we'll come on to the reasons why you do and don't have public in a minute. But if we look now, so now it's gone back green, and it will allow us to build our solution again. And as you can see, that all works great. But we made it work by changing the namespace to the same namespace as our playground project. Now that is actually a very, very bad idea, and I'll explain why. Let's say we were to create another library. And let's again create another object called my object. And again, we'll copy and paste the code in. Oops. In fact, to tell you what we'll do, we'll do it the easy way. What we can do is, if we just copy that file directly in. So now we've got my object. It's the same namespace again. So we've got two classes called my object, and they're both in the playground namespace. Again, if we go into that playground and add a reference to the other project, now when we try to build the solution, it fails. Now the reason why is, if we look down here, we can see my object exists in both of these two libraries, and that's the problem. We have now a conflict. We've got two objects in the same namespace of the same name, and we don't know which one we want to use. And obviously this is not a good way forward, because what might happen is you might write an object and you pass that object to another team, to another company, to another developer who wants to use your solution and your code, and if they bring it in and they've named an object the same in the same namespace, they're going to conflict and it's not going to work. So what do we do? Well, basically this is why we have namespaces. So if we go back into each of our objects and we change the namespace to what it should be, so in this case the namespace should be my second library, and in this one we shall call it my library. Well, now when we go to program, it's not there at all, but because we have a reference within the project, it knows where it should be. All we need to do is add a link to the namespace that we're using. So if we right click on our object, we have this resolve option, and as you can see, we've got using my library or my second library. So as you can see, we can now choose which one we want to use, and if we choose my library, what it does, it puts up here a statement saying using my library, and that is telling my program that it wants to use the my library namespace to try and find any objects. So it looks in there and it finds my object, and now it allows us to build it. However, we might actually want to use the my object from the two different libraries. So if that's the case, if we get rid of the using statement, what we do instead is we start typing in the namespace. So we type my library dot, and now we have my object. So that is referencing the my object in the namespace of my library. Similarly, for this one, we want to use my second library dot my object, and we just need to copy that to there, copy that new statement to there, and again now the entire application builds, and this object is using the class from my library, this object, this variable is using the object from my second library. So we're able to have two classes that are the same name, but they'll happily work dependently with each other simply by having them in a different namespace. Now in the real world, you will generally call your namespaces and your projects based around your company name. That helps separate your namespaces between other companies that might use them. And a common method for doing this would be using something that's unique to your company. So for example, a domain name that is registered to you. So for example, in my case, what I would generally do is when I create a new project and I want to create a class library that I know I'm going to want to share with a company or a developer outside my own company, I will actually call the library com.square connection dot my library, because I own the squareconnection.com domain, therefore it is unique to myself. Again, let's just copy the my object into there, go in and change the namespace to com.squareconnection.mylibrary and build that. And once again, we will simply add a reference to that. And so now, when I'm wanting to access the objects, oops, change that. Dot square connection dot my library dot my object equals new com dot square connection dot my library dot my object. So oops, checked 3. So as you can see, I've done the same thing here, but my namespace is much more verbose because I've started using my company name. Rebuild the program. Now if we right click my programs, the playground, and say open folder in File Explorer, we'll have this bin folder, so whenever you do a build it actually compiles everything and puts them in the bin folder. So we'll see we've got my library.dll, my second library.dll. Because they were just in a basic namespace, it's not very easy to know what they are, but this one, com.squareconnection.mylibrary, that means when I move that around now, I have a much greater chance that it isn't going to cause any conflicts. So to finish off about projects, I want to show you how you would consume or pass around this object we've just created. So in this case here, we've actually created this squareconnection.com and it's in the solution, and we linked it by going to references, add reference and solution. But we might not be in the solution, we may have compiled this and created it all on its own, and we need to bring it in separately. So if we build that and open the folder, just because I'm going to want to get to the DLL file, and then we're going to remove that from the project. So if we go to our program now and try to build, you'll see it doesn't like it because it can't find that namespace. What we need to do is in references say add reference, but instead of selecting a solution, we want to click browse, and then the browse button there. And what we want to do is we want to browse to the location of our file. So we can see our DLL library here and click OK. So we're linked to it there, and as you can see, it's now working again. So in this scenario, this is when you would create your standalone library and then you would give it to a third party who would simply add it as a reference by referencing the actual DLL file, and then once they have that DLL file, they can access everything within the code and the structure that you've created. Some of the features of object-oriented programming are things called encapsulation, inheritance and polymorphism. Now we went through them in the overview lecture, but it might be easier to go through it again with some examples. So what we're going to do, we're going to create a new class and we're going to call it customer. Now our customer class, it's going to have a customer ID, and it's going to have a name. Now this shows encapsulation. What we're saying is, because name is relevant to a customer and the customer ID is relevant to the customer, we want to encapsulate them within that object. Let's say we wanted to be able to update the name. So if we were to have a method called and we would simply have name, let's just start public void name equals new name. Now we've encapsulated the functionality within the class itself. What we wouldn't want to do is encapsulate it elsewhere. So for example, we wouldn't have void and then if we wanted to update the customer class, actually do it through by calling a related class, because that's not encapsulated. The update name is only really related to the customer, so we only want to keep it as part of that customer. Inheritance is about creating base classes that we can use to extend for other classes. So for example, we might have public supplier, and a lot of that code might be exactly the same. Class supplier, now this is a lot of code. We're duplicating a lot of code when we don't necessarily need to do. So what we can do instead is we can create a base class called person that contains the name and the method. So what we can then do here is we take those out and we can make these implement or inherit from the person base class by doing colon and then person. If we just make these public, and then we can see this easier in action. So what you will see in our program now is if we create a mylibrary dot customer new mylibrary customer, what we'll see is that we've got a customer ID and a name and an update name, despite the fact that actually the update name and name were not specified in either customer or supplier ID classes, and that's because they have implemented that person class. Similarly, we could have that as supplier and again we can access all the same properties. Now if we were to actually instantiate the person object, you'll see now that we've only got the name and update name. There is no ID property that we can access, and that's because the person class doesn't expose that method or property. We only get them when we actually use the customer or supplier classes. Now quite often when you have a base class, you have that base class because you want to do just this, and you would never want to use the person class directly. You would always want to inherit from it and then use the inherited class. So what we can do to prevent somebody accidentally using the myPerson class is we can say public abstract class, and that allows us to inherit from the class, but it prevents us from instantiating the class. So again, all we can do now is we can create a customer, but we can't create, if we try to create a person, it would fail. And as you can see, we can now access all the properties. So that's inheritance. The other item we mentioned was polymorphism. Now polymorphism is about being able to define the properties and the methods without actually implementing them. The idea being that we might want to have two implementations that implement something in a different way, but are in effect the same, use the same methods and signatures. And again, the example we used was a calculator. So let's create a calculate class. So in this class we're simply going to have a single method that we will call perform calculation. So we would have, and it's going to take in number 1 and a number 2. Oops. Int n2. And so for example we might want to return n1 plus n2. So within our main program, we want to add two numbers. We would say calc dot perform calc, and we would enter in our two numbers. But obviously calculators do more than just add. They also want to divide, they want to subtract, and they want to do lots of other different things with the two different numbers. So what we could do is we could simply have perform add, perform minus, perform multiplication. But then at some point in the future you might decide there's another type of calculation you want to do, and it's not always the best way to have to keep adding more and more and more methods each time we want to, and having to recompile and redeploy the application each time. What's easier is if you can inject a different implementation as is needed, maybe as part of a different DLL or as part of a system update. So the way we do that is we use polymorphism, and the way we do that is we use something called an interface. So the easiest way to get started with an interface, if we right click our calculator class, let's just zoom in here, take our calculate class, go to refactor, and we can say extract interface. There's only one method, so we'll choose that one and say OK. Now what's happened, it's created a second file called iCalculate. And as you can see, so we've got interface, we'll just make that public. Again, we'll come to why we make it public in the next lecture. And we are defining int performCalc, which is a method. It takes 2 integers in and it returns an integer. We don't have to precede it with I. That is just a common practice that you do to denote it as being an interface. You'll notice there's no implementation here. It is merely what's called the method signature. If we go to our calculate class, you'll now see that just like when we inherit from a base class, we also inherit from an interface. And so now we have int performCalc n1 and n2. But what we can do now is we can say add calculate, and then let's just create another method called subtract and multiply. Now in the subtract we want to do a subtraction, and there we want to do times. Now within our main program, when we define our object we want to use, we say my library.I calculate equals new. So we're defining an iCalculate calc function equals new, but then we need to tell it which implementation we want to use. So we're going to use the add calculate. Actually, we'll call that the add function, and then we'll do the same again. Subtract. So in each case we're using the same interface but a different implementation. Multiply calculate. So now we can say add function 10, 10. Actually, we'll get rid of that because even though generally you wouldn't do it that way, we would have function. So equals function. Okay, so function dot perform calc. So as you can see now, at this moment in time we're doing the add calculate, and if we just output that result, so because we're implementing the add calculate, and then when we run that it outputs 20. Now all we need to do is, if we change which method we use to the multiply calculate, you'll notice I don't have to change this line at all. It's still going to work. And now when we run it, we get a completely different answer because it's used a completely different implementation. So in the real world you wouldn't necessarily define these here. You might define them within a configuration file or some script logic or within a database, but in your main code you would perform all your work against an iCalculate class, against the interface class, and in some other bit of code you would swap in or swap out the the concrete implementation as and when was needed. So as you can see, by using inheritance, encapsulation and polymorphism, it gives you huge amounts of flexibility in how to build software, and just starts you along the lines of being able to build software more modular. As we go further through the course, you'll see these principles put into real world practices, and you'll get an even better idea of how it all hangs together. For the final lecture on object-oriented programming, I want to talk about access modifiers. Now, strictly speaking, it's not necessarily just about object-oriented programming, but it's the easiest way to explain it. Now, access modifiers define how you can get access to any particular class. The types you can have are public, internal, private, and protected. The most common one you'll use is public. If we take our customer class here, as a public class, when we call that class and that method, it means we can see both the method and both the class itself and the methods and properties within that class. If we go into the customer ID, for example, and we change that to private, well, now we can no longer see the customer ID, and that's because we've made it private. Another option we can have actually is internal. Now again, if we go to here, you'll see that we still cannot access that property, and the difference between private and internal is how they are accessed within the confines of a project or a solution. So for example, if we have it as private, it means we can access it within the same class. So we could have some method, and that would allow us to return the customer ID, because it's in this, even though it's marked private, it's saying you can access it within the confines of the same class. We'll just change that to int so that we don't get the error. Now, if we were to create another class within this same project, we create a method that doesn't really do anything, so we can create a customer equals new customer, and you'll notice that we still cannot access the customer ID because it's set to private. If we change that to internal, you'll notice now that we can access the customer ID from another class within the same project. But if we go back to our program that's in a separate project, we still can't access it. So that's the difference between private, public and internal. The final commonly used access modifier is the virtual keyword. If we just set these back to public just to show this example. The virtual keyword allows you to denote a method as overridable. What does that mean? Well, if we change this to virtual, what we can now do is in our base class we can say public override update name. And so what we can do now, we can have a call, we can use this base and implement whatever's that going to do, but then we can return something completely different. So what this is doing, it's overriding, obviously it's a returning thing actually. We can say name equals some of the value. So it's overriding this method. So it's saying when anybody ever calls the update name, instead of assigning new name to new name, we're just going to override it with our own value. Now if we take the virtual keyword out, when we try to compile, it fails because it's saying it cannot be overridden. Again, put it back in and it allows us to do it. So the virtual keyword is just to allow you to implement this functionality. Hi there, welcome to the section of the course about solid principles. Before we get started in writing any actual code, we need to understand why we're structuring the project and the code in a certain way. And a lot of the reasons why we do some of this is down to what are called the 5 solid principles of object-oriented programming and design. When working with software in which dependency management is handled badly, the code can become rigid, fragile and very difficult to reuse. Rigid code is that which code is difficult to modify, either to change existing functionality or add new features. Fragile code is susceptible to the introduction of bugs, particularly those that appear in a module when another area of the code is changed. If you follow the 5 solid principles, you can produce code that is more flexible and robust and that has a higher possibility for reuse. Through the next 5 lectures, I'm going to break down each principle in turn with examples of how we use them. Okay, so the first principle of solid is the S, which is the single responsibility principle. It states that there should never be more than one reason for a class to change. This means that every class or similar structure in your code should only have one job to do. Everything in the class should be related to that single purpose. Now this doesn't mean that your classes should only contain one method or property. There might be many members, but as long as they all relate to the same single responsibility, they will align to this principle. It may be that when a reason for a change occurs, multiple members of the class may need modification. Now application of this principle can change your code considerably. One key change is that the classes in your project become smaller and cleaner. The number of classes in a solution may increase, so it's important to organise them well using namespaces and project folders. The creation of classes that are tightly focused on a single purpose leads to code that is simpler to understand and maintain. Another benefit of having small cohesive classes is that the chances of a class containing bugs is lowered. This reduces the need for changes, so code is far less fragile. As the classes perform only one duty, multiple classes will need to work together to achieve larger tasks. However, along with other principles, this permits looser coupling, and it can also make it easier to modify the overall software, either by extending existing classes or introducing new interchangeable versions. So let's have an example. Let's pretend we have a class called product. Now in product we have 3 methods: check stock level, stock low, show stock alert. Now each of these are 3 separate distinct methods. Now they're all related to a product, however they all do a different function. So for example, the check stock level uses a stock service to go off and check the stock. Now this may be a call to an internal database, it may be a call to an external service. Either way, if that service changes, we must change this method accordingly. However, it would not affect these, and that therefore breaks the single responsibility principle. So what we should do is we need to what's called refactor the code or rewrite the code. As you can see here, we have 3 separate classes. Each class is responsible for each individual item. So we will have the stock checker, which interfaces with the service. We have a stock low indicator, which will interface and use the stock checker. And we have a stock alerter, which again will use the stock checker. So as you can see, they are now 3 separate classes and they all work together. However, each class is responsibility for only one single action. Next up we have O, or the open-closed principle. This states that classes should be open for extension but closed for modification. Open to extension means that you should design your classes so that new functionality can be added as new requirements are generated. Closed for modification means that once you've developed a class, you should never have to modify it except to correct bugs. Now these two principles may appear contradictory. However, if you correctly structure your classes and their dependencies, you can add functionality without editing the existing source code. Generally, we achieve this by referring to abstractions for dependencies such as interfaces or abstract classes rather than using concrete classes. Such interfaces can be fixed once developed so that the classes that depend upon them can rely upon unchanging abstractions. Functionality can be added by creating new classes that implement the interface. Applying OCP to your projects limits the need to change the source code once it's been written, tested and debugged. This reduces the risk of introducing new bugs to existing code, leading to more robust software. Another side effect of the use of interfaces for dependencies is that we reduce the coupling and increase the flexibility. To demonstrate this, let's consider some code that violates it and then explain how we can fix it. In this example, we have a basic module for logging messages. The logger class is a single method that accepts a message to be logged and the type of logging to perform. A switch statement changes the action according to whether the program is outputting messages to the console or a printer. If you wish to add a third type of logging, perhaps sending the log messages to a messaging queue or storing them in a database, you couldn't do so without modifying this existing code. First, we'd need to add a new logging type to the constants, and then for the methods of logging the messages. Secondly, you would need to extend the switch statement to check the new log types and output and store the messages accordingly. So if we refactor the code to take into account the open-close principle, as you can see, we use here an iMessageLogger interface. The iMessageLogger interface simply defines one method, which is the log method. We can then create 2 separate concrete implementations of that iMessageLogger. As you can see, we have a console logger that takes a string message and writes it to the console, and a printer logger that will output it to the printer. When we then come to use these loggers in our actual class, all we need to do is take in a logger and say messenger logger.log. As you can see, the actual implementation here is unaware of the kind that we are passing in, and therefore we can, if we need to create a new type of logger, all we need to do is create a new class that implements iMessageLogger, performs the logging accordingly, and then we inject it into our class that is using the code. Next we have L, or the Liskov substitution principle. This principle states that functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. For languages such as C#, this can be also read as code that uses a base class must be able to substitute a subclass without knowing it. LSP applies to inheritance hierarchies. It specifies that you should design your classes so that client dependencies can be substituted with subclasses without the client knowing about the change. Therefore, all subclasses must operate in the same manner as their base class. The specific functionality of the subclass may be different, but it must conform to the expected behaviour of the base class. To be a true behaviourable subtype, so subclass must not only implement the base class's methods and properties, but also conform to its implied behaviour. Once again, the best way to explain this is to show you some code. If we take a base class of product service, with the product service we can add new products and we can get new products. However, if we needed a product service that would only return products and we didn't want to allow people to add products, with this current class, what we would have to do is override the add method and throw an exception. This obviously breaks the Liskov principle. Therefore, what we would need to do is rewrite this class so as to not require us to override the add method. And the way we do that is by using the next principle. So that brings us to I, which is the interface segregation principle. Now, some classes have public interfaces that are not cohesive. They may include several groups of members where each group is used by a different set of client classes. The groups might be entirely separate, or there might be some overlap between the members used by different clients. Ideally, all classes should have cohesive interfaces, but of course this is not always possible. The interface segregation principle states that clients should not be forced to depend upon interfaces they don't use. When we have non-cohesive interfaces, the ISP guides us to create multiple smaller cohesive interfaces. The original class implements each interface. Clients can then refer to the class using the smaller interface without knowing that the other members in other interfaces exist. When you apply the ISP, classes and their dependencies communicate using tightly focused interfaces, minimizing dependencies on unused members and reducing coupling accordingly. Smaller interfaces are easy to implement, improve flexibility and the possibility of reuse. As fewer classes share interfaces, the number of changes that are required in response to an interface modification is lowered and therefore increases robustness. Okay, let's have an example. If you remember from the prior lecture, we had the issue whereby we had a product service that implemented two methods, an add and a get. However, there might be a situation where you would want a read-only product service that would only implement the get method. In this case, we had to override the base class's add method to throw an exception. Obviously, this isn't ideal. This is where individual smaller interfaces really come into play. So what we can do is we can write two separate interfaces, a readable interface and a writable interface. Each interface specifies the two different sets of methods. So for example, the read-only will be any get methods, the writable will be add, update, delete methods. We can then create our two individual product services and implement just the methods we want from the base interface. So for example, the read-only product service now just implements the readable product service. Whereas if we want a service that has full read and write capabilities, we implement both of the services. So as you can see, we can write two separate product services that implement just the interface we want to use. It also means if we want to make change to the writable service, it will not have any effect on the readable service. Finally, we have D, the dependency inversion principle. The dependency inversion principle states that high-level modules should not depend on low-level modules. Both should depend upon abstractions. Secondly, abstractions should not depend upon details. Details should depend upon abstractions. The idea of high-level and low-level modules categorises classes in a hierarchical manner. High-level modules or classes are those that deal with larger sets of functionality. At the highest level, they are the classes that implement business rules within the overall design of the solution. Low-level modules deal with more detailed operations. At the lowest level, they may deal with writing information to databases or passing messages to the operating system. Of course, there are many levels between the highest and the lowest, and the DIP applies to any area where dependencies exist between classes. The easiest way to describe the DIP is with an example. Consider we have a banking solution. As part of the software, it is necessary to transfer money between accounts. This may involve a class for a bank account and an account number and a balance value. It may include methods that add or remove funds from the account. To control transfers between accounts, you may create a high-level transfer manager class. This may have properties for the two accounts involved in the transaction and for the value of the transfer. For example, as you can see, we have the individual classes for the bank account here, and the transfer manager takes a bank account source, a bank account destination, and implements the transfer. But as you can see, the transfer manager is directly implementing the bank account class. Should we need to make any change to the lower level bank account class, this could have a direct impact on the transfer manager or any other class that implements one of the bank account classes. Using the dependency inversion principle, what we need to do is create two separate interfaces, a transfer source and a transfer destination. Each one is responsible for the method we want to implement. When we then create our bank account, we implement both these services. Therefore, when we come to creating the transfer manager, instead of referencing the concrete implementation of bank account, we just reference the interfaces that we are bothered with, depending on whether it is the source or the destination. That way we can substitute different classes provided they still implement those interfaces, and it makes our application more loosely coupled.
The following lectures are going to be about the basics of MVC. So we're not going to go into great detail of how we would build a real world project, but it's about to try and explain to you the core concepts and the basic tools and methodologies that we use for building websites in general. If you recall from the course introduction, web servers basically generate pages from a mixture of back-end code and HTML templates. As a user requests a page, the server may query a database or run the code, combine it with the HTML within the template, and then return a rendered page to the user. With MVC, this whole concept is broken into three different areas. There's the model, which is essentially the data that we want to return to a user. We have the view, which is the HTML and the design, basically the page that the user receives and interacts with. And then we have the controller, and it is the controller's responsibility to take interactions from the user, access data in the model, and return it back to the users as appropriate. Therefore, over the next few lectures, we're going to learn the basics anatomy of an MVC website. We're going to go through how we manage and create these models, views and controllers, and then finally we'll have a brief run through of the built-in security mechanisms that you can use.
Let's get started and build our first MVC application. If you've not done so already, launch Visual Studio, then go to the File menu, New and Project. We'll be presented with a series of different templates we can use for building various kinds of applications. So for example, we could build a Windows classic desktop application, but what we want is a website. So we'll make sure we have the web selected here. Also make sure that we're in the C# node. And we're going to want the ASP.NET Web Application .NET framework. The core web applications is a cut down and streamlined version of .NET that runs on other platforms such as Unix and OS X. The majority of web applications at the moment are still built using web applications and the standard .NET framework, so we're going to go ahead and continue using that. So make sure that one's highlighted, then let's give our application a name. Click OK, and then we can choose what style of web application we want. So for example, we could create an empty application, or we could use a web forms application, which was one of the original iterations of building .NET apps. The one we want, obviously because that's what this course is based on, is MVC. You'll also notice we've got Web API, SPA applications, and even Azure applications. Technically speaking, we wouldn't need to use any of these. We could just build our projects from the ground up and manually add in the various different libraries that we need and build out everything else, such as the controllers and the views. But by using this template, it adds in a lot of the boilerplate code that we need to use and takes a lot of that hard work away from us. It also gives us a number of examples that we can use and build upon, which is very useful, especially when you're starting out. We also have this option to set different authentication types. So for example, we can use individual user accounts, whereby the template would set up a model and a local database so that users could register and store accounts. We could also use Windows authentication, so it could integrate with things such as Active Directory or a local Windows database. To keep things simple, we're just going to go for no authentication. We will look at authentication later on, but for now let's just stick with the basics. When we're ready to go, simply hit OK. Once that's finished, we'll be presented with a page similar to this. We'll see our solution here on the right hand side, and underneath we'll see the various different folder structures underneath it. We'll go through these later on, but for now just note how we have our controllers, we have a models, and we have a views folder, i.e. the MVC of a model view controller app. To launch our project, simply go to the debugger up here. By default it will take your default web browser. Hit the left mouse button and this will start Visual Studio in the debugger. And as you see, that will launch our web page, and it's a very basic web application. We've got a few pages we can navigate around, but the point is it's now a fully functional website, and all we've had to do is create a new project based on that template. Also note that because this is running in the debugger, we can see various bits of information. So for example, we can see how much memory we're using. It would also allow us to set breakpoints and actually debug the back-end code. If we want to stop the application, simply hit the stop button there, and that will stop the application running. So if we went back to our website now and tried to navigate round, we'd find it would time out because the application is not actually running. We don't have to actually run the application in the debugger. We could instead right click on our solution and say View in Browser. So what that does, this still launches our ASP.NET web application, but now we've got none of the debugging tools. This is an important thing to understand, because if you want to actually debug the backend code, then you need to actually fire it up in the browser. But if you need to make any change to the code, you have to stop the debugger, make your changes, and then relaunch it. Sometimes that can be quite cumbersome. So sometimes what we will do is we will right click and say View in Browser, and then when we can make changes, if we make changes to static HTML files, we simply save the page and then reload it. Or if we make changes to the backend code, we can just rebuild it and reload the page without having to go through restarting the debugger process again. We'll see that more in action as we go through the various parts of building up the project. So for this lecture we'll leave it there, and in the next one we will start going through what all these different folders are and what actually makes up an MVC project. Let's have a quick look round what has built our actual MVC website. First, at the start, I said that the MVC template basically includes a bunch of links or references to other libraries. Now these libraries can come in two types: software development kits or SDKs or NuGet packages. If we look underneath our project, we have this references node here. And if we click the little arrow, it expands to show us all the references that we've got within the project. If you highlight any of these particular libraries, the details of them will appear down here in the Properties dialog box. The easy way to tell if a package is a NuGet package or from the SDK is by looking at where it's located. So for example, if we look at the Antler 3 runtime, you'll see that the path is set to your users, your username, documents, the name of your application, packages, and the actual DLL itself. And that's because this was built using NuGet. So we went into, or the NuGet packager downloaded this runtime or this library down from the internet and stored it locally with our package. Now let's have a look at a simpler one, which is system. And now notice that the path is in C programs reference assemblies. That's because these components came part of an SDK or a software development kit, and therefore they are core to the computer, or they are installed, in this case on your local computer, or more usual when you deploy it to a server, they are deployed to a server and part of that core system. SDK packages are added by manually selecting them. So for example, if we wanted to add another package from an SDK, we would right click our project, say add, and then choose reference. And here we get all the built-in references that have been installed onto my development machine. I've actually not installed any additional ones other than the standard .NET SDK that is installed as part of Visual Studio. Sometimes you can install other SDKs and they might appear in here. If you wanted to add an additional package, for example, if we wanted to add the system.data entity package, we would simply put a tick box by it and then click OK. Similarly, you can actually browse directly to an installed package if an SDK that's been installed hasn't put it in the standard locations or registered within the computer, which does sometimes happen. Now let's right click our project again, and this time let's go to Manage NuGet Packages. This will bring up all the installed NuGet packages, and if we click on them we get to see more details about the package, such as who wrote it and what version is installed, plus any dependencies that a package might have. Along the top you'll also see we've got a browse and update buttons. By going into these we can either add additional packages that we might want to add, or when packages get updated then Visual Studio will inform us that their updates are available and we could go into them and update them here. We'll add more NuGet packages later on, but for now let's just close this window. So we can see as well that our package has a number of folders, and each contains classes, HTML files, JavaScript files, and so on and so forth. Some are quite self-explanatory. For example, our models will go in our models folder, controllers in the controllers folder, and views in the views folder. We have an app data folder. This generally isn't used so much anymore. The idea being, if you wanted a static or local database, you could put it in this folder. More often than not, data will get stored either in an external service or something such as SQL Server. But if, for example, you're going to use something such as SQLite, then the file might go in here. AppStart contains a number of special classes that control how our MVC application itself is configured and what it does when it starts up. We'll look at these more later on, of course. Next we have this content folder. So the content folder will store what is usually static content. For example, it's common practice that we would put an images folder under here and put images in there. By default we have these CSS files, which are our standard cascading style sheet files. As you can see, by default we get a very basic site CSS which just sets some basic styling, And we also have our Bootstrap library, which was installed as part of NuGet and is included in a standard MVC template. This is what applies some of the more advanced styles that we see throughout our application. We also have a scripts folder that includes all our JavaScript files. Again, all these are included in the template. So for example, we have our Bootstrap JavaScript file that contains JavaScript code for controlling some of the more advanced elements within Bootstrap. Unfortunately, the use of CSS and JavaScript and Bootstrap are all very large subjects in their own right and therefore can't really be covered in any detail in this course. But as we go through the various projects, we'll start to delve in bits into each of these and we'll pick up some of the features. If you want to know in particular more about HTML and CSS, please check out my course on HTML on CSS that goes into how to actually build up HTML tags and control all the styling and so on. As an existing student, I always give special offers, so look out for my emails. And finally, at the bottom, we have a bunch of files here. Most of them you don't need to worry about. Probably the most common one you will use is the web.config. In here we can store information or configuration items that can be then accessed within our code. These settings might be changeable over time, so we would include settings in here that we wouldn't want to include should it change quite often. For example, database connection strings you would normally store in here rather than hard coding it in your application. Similarly, contact email addresses, contact details, if these might change, you might store them as a configuration setting and reference it from this file rather than again hard coding it within the website itself. In the next few lectures, we'll start delving into the controllers, models and views folders. MVC stands for Model View Controller. However, I'm actually going to go through the MVC acronym backwards. Personally, I think it makes more sense this way. Controllers, the C in the MVC, control program logic. They contain all our server-side dynamic code. However, they are also the starting point for defining our view entry points. In other words, without a view being defined in our controller, MVC doesn't know how to display the view. Therefore, the controller has to come first. Open the controllers folder and double-click on the home controller. MVC sets the home controller as the default controller. And within any one controller, we can have a default page which is indexed. This can actually be controlled through configuration, but by standard this is how it's done. So when we go to our front page and we have nothing after the main web address, it knows that to default to the home controller, and because we've got nothing to define the view, it knows to default to the index view. We can see the controller itself is just a standard C# class, and we've called it home controller. And notice this, in case you can't remember or you haven't been through the C# basics lectures, this means that it inherits from a base class. In this case, it inherits from the controller base class. By hovering over, we can see some more details about it, specifically what namespace it resides in. So here we can see it's inheriting from system.web.mvc.controller. This base controller has a bunch of methods in it that provide some core functionality within our applications, and by inheriting from this controller we get all that functionality out of the box. Generally we don't need to care about a lot of this except for more advanced scenarios, but in case you are interested, and sometimes as a developer you like to know these things, we can see what makes up the home controller by right clicking on the controller and then saying go to definition. Alternatively, we could also press F12. So this takes us to the class definition for the controller class. It's not the actual class itself, so we can't see all the logic that was built into it. Instead, it's more the framework around it, and it exposes and shows us what all the different properties and functions are that are included. At the top we'll see this assembly, and this is the name and version of the library that the controller class actually resides in. And in fact, when we hover over it, we can even see the exact location of the library that it's contained within. In this case, Microsoft ASP system.web.mvc is part of the Microsoft.asp.net.mvc NuGet library. In other words, it's not part of the SDK, it was added as a NuGet package. And as mentioned down here, we can see that we have all these properties and methods that are part of the core controller class, and technically speaking we can actually call these should we need to. However, for the most part they are just part of the core MVC structure and are called by the MVC subsystem when the website is running on a server. It's also interesting to note that the controller class itself is also abstracted from other controllers and interfaces. And finally, you'll notice that it's an abstract class. That means that we cannot actually instantiate a controller on its own. We have to create another controller that inherits from it and use that instead. Let's go back to our home controller. We can see three methods are created for us by default. The index, which as I've already said is the default view. We've got an about and a contacts view. At the moment, our views really just do the same thing. They return a view. Each method is of the type action result, and it's part of the system.web.mvc namespace. Action result is essentially just a view. However, it contains a few additional properties that we can hook into and use. For example, in the about and contact views, you'll notice that we've got this viewBag.message. The viewBag is a special property of the action result class that allows us to store ad hoc information in it as key pair values. The viewBag gets passed back to the view when it's processed, and this allows us to access any information in the back end that we might store. The easiest way to demonstrate this is by example. Launch our site by pressing the Start Debug button again, and as before, this will launch our site in a browser and take us to the default main page. We'll see some basic styling and ASP.NET information. Again, this is all just the sample HTML code that comes as part of the template. But let's click this About page up here, and you'll see here that we've pulled through the text Your Application Description page. So this is the text that was added to the viewBag.message in the controller. So let's have a look at the actual view itself to see how we got it from the controller through to the HTML page. Stop the debugger, go into our Views, Home and About page, and this is our basic page. So at the top we'll see this @ symbol followed by an opening curly bracket, which is the same kind of curly bracket we get when we're writing C# code. We'll also notice that it's highlighted in yellow. This just helps us point out that within the HTML which bits are actual embedded C# code and which is HTML itself. All C# code within a HTML page will be embedded in this fashion, either using an @ symbol followed by curly braces, in which case we have C# code blocks between the braces, or sometimes we can inject individual items of C# code without the curly braces. So if we look at this first one here, we've got this @viewBag.title. So rather than using the curly braces, which could have more complex logic in it, This simply just says access the view bag and print out its title property. So we'll look down here in the heading 3 tag, and again we've got this view bag, but this time it's displaying the message. And this is how in our HTML page we can then access the view bag collection from within our HTML page. This mixing of JavaScript and HTML in this format is known as the razor syntax, by the way. We're not limited to the title or the messages in the view bag either. In fact, view bag is a special class that allows us to create on-the-fly dynamic properties. In other words, we can assign a value to any property we like, and unlike standard C# code where we might have to build a model and define the properties we want to assign it to, in a view bag these properties are completely dynamic. Let's take an example of what we mean. If we go back to our controller and access our view bag collection, if we hit the full stop to try and get a collection of properties, you'll notice nothing comes up. So let's make one up. What I'm trying to get at is here that this is not something that is baked in, it's something that I've just made up right here and now. It's nothing we've had to predefine. So now we can assign some more text to it. Save the controller and go back to our HTML page. Now let's reference the extra view bag property we've just created. We're going to do it in just a standard paragraph tag. And again, as we have done on the previous lines, we simply do our @ symbol to tell it we're writing some C# code. We're telling it we're going to access the view bag collection, and then we're going to tell it what it is that we want to access. Now I'm going to actually copy and paste that there because we're not using predefined objects. It doesn't know what it is, so we have to manually type it in. Then we can save that and again run our project. So now we can see it has added this additional text to our page. Of course, this is quite simple stuff, and in fact, given that we're essentially passing static text through to the page, we might as well have just manually added text to the page. But we're trying to illustrate that we can send information to our HTML very easily using this view bag class, and in fact using the controller and view interaction. As a final step, let's have a look at how we create new controllers. At the moment, everything's been done within our home controller, but that's not always the case. Sometimes we will want different controllers or more controllers to help separate our code. For example, our admin section might want an admin controller. Somewhere where we manage or display products might want a product controller. A suppliers manager might want a suppliers controller, and so on. Adding a controller is easy. We simply right-click controllers, go to Add Controller. We have a number of options. For now we'll keep things simple. Just select the top one, MVC5 Controller Empty, and click Add. And then we give it a name. We can call it pretty much anything we want. For example, we could call this one Products. However, we need to make sure that it's got controller on the end. And click Add. This creates a basic empty controller with just an index page. However, it's important to note that we've now in our views got this additional folder here called Products. And in fact, if we were to go and add a new action result or new pages to this controller, they will all appear under the Products view as opposed to the Home view. So with that in mind, let's start looking at views. Views are the V in MVC. They hold all our HTML code, any on-page styling, and they allow us to, with the ability to mix in the C# code as well, as we've just seen. With the C# code, as we've shown, we can grab values and data that has been presented from our controller to display it on the page. When we mix our C# code in our HTML pages, we are using something called the Razor syntax. Razor is simply the engine that the MVC uses to process our C# code to generate the necessary dynamic HTML. Note that our view pages themselves actually have a different extension. If we go into our views folder and look at them, we can see they've got this CS HTML extension. This is a special extension that helps the MVC runtime identify pages that should have dynamic content. If we just created a plain HTML file, MVC wouldn't know how to process any code within it, and it would just all display as static text. Also, when linking to pages, for example, if we wanted to link to our About Us page, we don't link to about.cshtml. We actually create a link to About with no extension, and we'll go into that a bit more detail. But as a bit of an example, let's look at the index page. So as before, this was a page that is automatically generated when we create an empty website. This page has much more HTML markup to it, but that's all. It's just basic static HTML with very little built-in C# code. In fact, at the top all we've got here is something that just sets the viewbag.title. And all that does is sets what appears in the browser title when we launch the site. We can see that at the top we've got this div here with a Jumbotron class, and some other divs and further blurred throughout the page. The base MVC templates use Bootstrap for styling, and so we can see references to these various Bootstrap classes such as Jumbotron, Row, Col MD4. These are the standard styling classes. As this course is about C# and MVC, and because HTML, CSS and Bootstrap are such huge subjects in their own right, it's a bit beyond this course. However, check out the HTML and CSS styling course if you want to learn more about that and go into more detail. So let's just run the site again. So you'll notice that we have all our blurb here is exactly what we've written in the HTML page itself. It's all static text. You'll also notice, however, that the bits at the top and the bits at the bottom don't actually appear in our HTML code. So for example, we've got this menu bar at the top with the application name link, home, about, contact. We've also got this footer at the bottom with a copyright blurb. But there is absolutely no reference to any of this within our index page. How do we get it there? Generally, when you build a website, you want to give it a consistent look across pages. For example, we always want the same colour scheme, the same menu bar, footers, and so on. MVC allows us to create a special shared page called a layout page. And this page contains this static content that's used throughout the site. So let's go and have a look at that page now. In our views folder, you can see this folder called shared. If we expand that, we can see this underscore layout page. So this file is a much more complete HTML file. For example, it contains our standard HTML opening tags. We've got our header tags with some scripts and a title set. And then we've got up here, we've got a navigation bar, which is where we define our links to our root page and home, about and contact pages. Then as we go down, we see this @render body tag. This line injects whatever page we are viewing, for example the index page or about pages, into the overall flow of this template. In other words, any HTML that we want to appear on all pages, we would put in this file, and the individual file that we're looking at, so for example the index of the contact page, would get injected into this bit where it has render body. In this way it mashes the pages together. We can also use something called partial views. This is a similar concept in that you can use it to embed other pages, which can be useful for reusing common pages that might need to be used repeatedly. The biggest difference is we can use partial views in any page, not just the layout page, but we'll come back to that in a later lecture. For now, the important key to take away is that our views or our HTML pages themselves can be a mix of static text and C# code, and they are a combination of the layout page, our individual design pages, and potentially any partial views that we might create. In the next chapter, we'll start to look at models and see how we can pass more complex objects through from our controllers to our views. Finally, we come to the section on models, the M in MVC. As we have seen, MVC renders web pages using a combination of controllers and views. Views contains a mixture of static HTML plus our Razor or C# code for generating dynamic content. In the previous examples, we defined our dynamic content in the controller and put that content into the view bag, which we could then access within our views. Using the view bag is fine, but it's really best for storing simple information. If you want to store anything more complex, or indeed if you want to be able to send information into our controller, then we need to start using models. A model is essentially an object that can store data. You could return simple data such as a string or integer. However, as we've seen, this could easily be achieved using the view bag. Models can be far more complex, however, and can be a combination of strings, numbers, booleans, even lists or further models. The easiest way to show this is with example. Let's start by creating a simple model. By default, we should have a models folder created for us. So if we right click on there, and then we're going to say add class. We're going to call our class customer and click add. So this is just a standard C# class, and we're going to follow the same patterns as building any C# class. We're going to create 3 properties. Obviously in the real world you might have more, but we're just trying to keep things simple. First we'll create an ID. Let's also have a customer name. And finally we'll have a telephone number. Once we have our model, we can then start to create an action that will be used to send that model onto an actual view page. So let's create a new controller action. And we'll call the action view customer. And all we're going to do is create an instance of our customer. The reason why we've got an error here is because our controller class doesn't know what a customer is. So what we need to do is right click, say actions and refactorings, and tell it to use the hello MVC.models. So this tells it where the namespace is for our customer model, and as you can see, the object now turns blue. Now we've created our customer object, let's assign some basic information to it. When we start storing objects in databases, we generally need some way to be able to uniquely identify that object, and the most common way of doing that is by creating an ID. We're using something called a GUID, which is a random alphanumeric string that the computer will create when we call this new GUID method. And then we convert it to a string to store back in there. We could actually save it as a GUID itself, but I like to get into the habit of saving it as a string because it gives us more flexibility going forwards. Now let's just set a customer name. And let's set a telephone. And finally, we'll return our view, but whereas before we've just returned empty views, now we're going to return the view with our customer object inside it. So that's our action controller created. What we need to do now is create a view page to actually display that information. Right click our view customer action, and now we can click this here, add view, which will go ahead and create our actual CSHTML page. We have some options here. We're going to ignore them for now, but we will come on to them in a couple of lectures time. But for now, just click add with all the defaults selected. And we'll get a largely blank page created. As we've seen earlier, all we're doing is we're setting a title. We'll just put a space in there, and we get a header. So in order to be able to access the object we've just passed through to the page, we need to know what kind of object we're expecting, and we need to tell our HTML page what that is. So we do this by adding a using statement at the top of the page, in a very similar way to how we add references to external classes in our standard C# classes. But here, rather than the using statement, we're going to use the @model. So again, because we're using the Razor syntax, i.e. embedding C# code in our page, we need to prefix our code with an @ symbol. We use this model because we are telling the page that this is what the model definition is going to be. And then we need to give it the full path to the actual model itself. So we actually have to go into hello MVC, models, and customer. So now we have this reference, our page knows what kind of object it's dealing with. And now we can start building our page up. And we can say @model. Note this time it's a capital M. Then when we hit full stop, we will get the options that we have because it's a customer. So let's display the name. And then we'll display the telephone number. So we can now build and run our application. Rather than running the full debugger, which sometimes takes a little bit longer, what we can do instead is simply go into our views, right click our view customer CSHTML page that has just been generated for us, and then we can say view in browser. So this will launch an instance of IIS in the background and then display the page that we've just selected. And as you can see, in our resulting page we have our static HTML as defined here, and then we have the dynamic object and the information it contains printed out here. And that's as simple as it is for passing a model back to the actual controller. And that's as simple as it is for passing a model from our controller to our view page. The previous example showed us how easy it was to construct a model in code and then send that model back to a view page via the controller. Quite often, however, we also need to send data back to the server. So for example, if a user wants to fill in a form to submit some information to you, we would do that via a page with some input boxes where they'd then hit a button that would send the data back to the server. Models are a great way of performing this action as well. So let's go ahead and show how we do this. The first thing we're going to do is create a new action result. And we will call it add customer. And all we're simply going to do here is return an empty view. Because all we want first is an empty page that we can then put some HTML on. So as we did before, I'm now going to right click there, click add view. Again, we're going to leave all the defaults here and click add. So now we're going to create a standard HTML input form. In brief, what we do is we create a form control, and in there we configure it to tell it where we're going to post that data to, i.e. the name of an action endpoint on our controller. So what we're going to do is post it to our view customer page that we've already got. We'll then add some input elements, and these will define and create elements on our HTML page to allow the user to input some information. And then finally we'll add a submit button on the end. So again, let's just tidy up a little bit of this code and we'll start creating our form. We'll set the action to add customer. No, we won't. We will set the action to view customer. Now we will create two input buttons, two input tags, which we say are a type of text. So this tells the HTML to render an empty text box. We need to give it a name, and the name will be how we will reference the information we're posting back to the controller. So we will call this name because it's going to be the customer name. Now let's do the same for telephone number. And then finally we need another input, but this time it needs to be a type of submit because this is going to submit the form, and we're going to set a value attribute, and what we put in this value attribute is basically the text that will appear on our submit button. So we will click add customer. So now our HTML page is set up. We need to modify our view customer action. So now we're going to be posting some information through, and we need to inform this controller endpoint that actually it's going to be receiving this information. So we're going to tell it we're going to be receiving a string called name and a string called telephone. Again, we will create our empty customer object. Again, we will generate an ID ourselves, but this time, rather than manually entering the name, we're going to tell it to set the name as the string that we are passing through, and the same with the telephone number. So the important thing to realise is that the name there matches up to the name there, and the string telephone there, the variable name, matches up to the name of that point there. So again, let's build our project. Now let's click on here and say View in Browser. So now we can type in some information, and this time when we submit it, it's now going to display the information that we've passed through from the previous form. And just to prove that, we'll go back, enter a different name, and add again. And as you can see, the information has been updated. So in this example, we've specifically told our action, our view customer action, that it's going to receive a string of name and a string of telephone. However, since we've already defined an actual model that has these properties, i.e. the customer object, we could in fact tell the action simply to expect the customer model instead. Now this is extremely useful when our objects become more complex. So let's get rid of these here, and this time we're going to tell it it's going to receive an object of customer, and we're going to call it posted customer. And now we're going to tell our object that actually the information that we want is within this posted customer object. Now, strictly speaking, we don't actually have to do this. We could, in theory, simply set a GUI to our posted customer and then return it. But I wanted to do it this way just to show you the full process as it happens. What we also want to do now is, just to show how things are coming through, is actually debug this so that we can step through what's actually happening. So let's move our mouse over to here to this grey bar, just by where we create our view customer, and click in there so that we get this red circle here, which is toggling what's called a breakpoint. So now when we run our code and we get to this line of code, it will actually stop and allow us to start running through. So let's click the debug start up here. So this time we're going to have to manually navigate through. So in our bar at the top, type home / add customer, and then it will take us to our page. And again, let's fill in some information and click add customer. Now, if we hover over our posted customer, we'll see here that we can see the object. And if we click this triangle here, it then opens up and shows us the information that we've posted through. So we can see actually the information that's coming through to the controller. The other way we can see this information is down here in this locals window. Again, if we click the triangle, we can see that information. So as we step through our code, either by clicking this step into button here, or as indicated by pressing F11, we can skip through the code and we can see it then generating and creating our customer object to when we get down here. So we have our generated customer object that contains our ID that we've just generated, a name and a telephone number. Then hit continue, and again we get to the page and it works exactly as it did before. So the important part to take away from this again is that for our input tags, what's the important thing is what we set as the name, because these items that we put in the name have to be exactly the same as we have defined our customer model. If we didn't, then the MVC system wouldn't know how to match up the data we're posting with the model that it's expecting. And this is very, very important because I myself have spent many an hour debugging application code such as this, only to discover I've misspelled a property name. So it's a very important thing to try and remember. Working with models is great, and as you can see, they make moving information between our HTML page and the backend controller really easy. However, having to manually crank out HTML page for our models, especially when our models get quite big, can become very tedious. Luckily, Visual Studio has a feature called scaffolding, and it's a bit like the template that gets created when we first create our ASP.NET project. The difference is we can make it automatically build individual pages based on the models we've created. We've actually already seen this scaffolding in action when we click our Add View button, because the page that is generated has some very basic HTML in it. But if you remember, there were other options we can add in that page. We can make the scaffolding do two things. First, let's create some individual pages. We're going to create another action controller, and this time we're going to call it Customer List. So to start with, we're just going to manually add some customers in code and then return them as a list of customers. So let's create a new list object that's going to contain a list of customers. And then we're going to add a couple of customers to the list. So we don't really need to bother with the ID just yet. If we copy and paste that line and then just update some of the information in it. And finally, we're going to return our view, and we're going to pass the customers list through to the view. So as we did before, we're going to add a view page, so right click customer list, click add view. But this time we're going to set some of these options. The first thing we want to do is tell it what template we want to use. So what we want is this list option here, because we want it to create a list of models. The next thing we need to do is tell it exactly what model is going to be used in that list. So if we look through here, we'll have some other classes here. These are just some of the built-in classes that MVC uses. The one that we want is this customer, and we know it's ours because it's in the models namespace there. And then simply click add. So you will now get the following HTML page generated. Before we go through it, let's actually see what it does. Build our solution, go into our views, right click the customer list page and say view in browser. As you can see, we now have a nicely rendered list of customers with links to either create a new customer, edit, view details or delete. Now none of these links will work yet as we haven't actually created the necessary pages. So let's have a look through the HTML. First, as before, at the top of our page we have to define our model. The slight difference here is we're actually saying it's an IEnumerable, which basically means it's going to be a list of the object. We then have this action link, and this action link is creating this piece of HTML here. It's creating our actual link to where we want to go. Now we could type in a manual link by telling it to go to home/create or whatever it is we're going to create, call our end page. So for example, add customer. But the action link automatically generates this information based on what we want the page to be. So in this example, we're saying we want to use the text to be create new and the endpoint to be create. And if we hover over action link here, we can see here that it's saying string link text and string action name. Now this assumes that the page that we're going to post to is actually on the same controller, in our case the home controller. If we ever had to, you can actually override this. We can simply put another option in and tell it which controller to go to. So that's handy to reference for later on when we maybe don't do everything through the home controller. The other thing to note is the templating assumes a certain way of naming our pages. So for example, it's expecting a page called create, and if we just scroll down to the bottom to where we have our other links, so we have an edit page, a details page and a delete page. Because we're doing everything in our home controller, we're actually being a bit more specific with what we call our action link. So rather than details or view, we're actually saying view customer or add customer. So the first thing to do, let's just update that create new to add customer. So the next thing that happens is we have some standard HTML to start creating a table. We have a header row here, and then we have this @HTML. So the @HTML is a class that has a number of methods in it for automatically generating HTML with data in it. We have our first method, which is display name for. So the display name for expects to take in what's known as a expression, or so as we can see when we hover over, we can see it's expecting expression func customer string, and this is what's known as a lambda expression, and we use this syntax here, and this is rather like when using LINQ for querying lists and things, which is basically we define what we want our variable to be called, then we have this equals greater than, and then we have our variable name again, and when we hit the plus, it knows that what our model is going to be, so we can then select what information it's going to display. And the display name for basically makes the HTML print out what the name of the model is. So not the data in the model, but the properties on our model. In this case, that's going to print out name, and this is going to print out telephone. Then we have a for each loop. So because this is a IEnumerable model, an IEnumerable or a list of our models, the page knows it can iterate through each of the items in that list. And then we're saying for each item that's in our model, because don't forget here, the model is not the customer, our model is a list of customers. So it's saying for each one of those, now we'll do a display for. So this is slightly different than display name for, it's display for. Again, the same kind of lambda expression context, syntax, but this time it's going to print out the value of what's in there. And then finally, as we said before, we get our links here. If we save that and then go back to our page and refresh that customer list page, then if we hover over our create new, if we look at the bottom just down here, we'll see that now the link is home/add customer, whereas before it was create. And that is because simply in here we updated our HTML link there. So that's how easy it is to create a link, a page with scaffolding. Let's now look at what other kinds of scaffolding we can use. In the previous lecture, we saw scaffolding generate a page with a list of objects. Now we'll explore some of the other templates. First, we're going to explore the create template. However, before we do this, we need some way to store our data. Normally we would connect it to a database. However, to keep things simple, and because we'll be looking at databases in more detail later, we're going to use something called an in-memory cache. An in-memory cache will allow us to store data in the computer's memory, and it will stay in the memory as long as the service is running and we haven't specifically cleared it out. This is very handy for testing, as it's far simpler than connecting to a database. But before we do that, we're going to have to add a few references to our project. So first of all, right-click our references and say Add Reference. Make sure we're looking at Assemblies, and scroll down until we see system.runtime.caching. Put a tick there and then say OK. Now go into our home controller, and what we need to do is create an internal list that can be accessed throughout the rest of our code. We also need to actually create our cache itself to store that list. So the first thing we'll do is create what's called an object cache. We'll need to right click on there, quick actions using system.runtime.caching. And we're going to tell it to use a memory cache, and we're going to tell it to use the default memory cache. Next, we're going to create a list of customers. And then we're going to create a constructor for our controller. So we're going to do public home controller. And this is code that will run whenever we hit any endpoint. And so we're going to say the customers access the cache. And we use these square brackets, and then we tell it what we are calling the cache. So in this case we're just going to call it customers. So then whenever we want to access that cache later, we just try and we use these customers. However, we also tell it that it's going to be storing the information as a list of customers. So we use this as list, so just telling it how it's going to be stored. But of course there might not actually be any information in there, so we need to check customers and see if it's null. So if it's null, it means we've not got any data in there, in which case we need to set customers as a new list of customer, and then needs to be two equal signs. Then we're going to create a method called save cache. And this is going to simply store whatever is currently in our list of customers in the cache. So again, we'll tell it where we're storing it in the cache, and we're saying that is going to be our customer list. So whenever we call this save cache, it will store our customers in memory, and every time we launch this controller, it will check see if there's anything in the memory, and if not, it will just create an empty list. Okay, now let's add our add customers page. Now we've already done this earlier, so what we're going to need to do is delete the add customer page we created earlier. because we're going to regenerate that page. And where we've got our add customer here, but what we're actually going to need to do is create another add customer action. See, this is a common practice when we're using especially scaffolding, because the first action endpoint will tell it to expect nothing, so that's just going to return our page that we will use to capture our data. However, the scaffolding, when it automatically generates our form for posting the information back, it will actually set the action, i.e. where it's posting it to the same name as the page we've used. The difference is this time is that this is actually going to contain a customer object. So let's go ahead and start building that endpoint. So our first endpoint is fine. And this time when we're posting back to it, it's going to be receiving a customer object. So let's set the ID. Then we're going to add that to customers, and then we're going to save the cache. You'll notice here that we've got this that both these are called add customer. The reason why it's still happy is because it's like overriding methods, because that's essentially what we're doing, which is one method has nothing in the input parameters in the signature, whereas this one does. But we can also further make sure we don't accidentally call the wrong controller. By default, this controller will accept different types of calls to it. However, by default, it will expect a HTTP GET. So what the other common practice is, we would decorate this one with a HTTP post, which is a special kind of post that we will make to this web page because we're actually posting data to it. Finally, we need to return this somewhere once we've actually added our customer. Now, because the object's already created, ideally we don't want to just return it back to the same page again, because the customer's already been generated and it would confuse the system. So the options that we could do, and these are not technical requirements, these are just suggestions we could do, is we could redirect them to a customer details page, which would be a read-only view of the customer we've just created. Or we could send them to like an edit customer page, which would pretty much look like the page we're doing now, but this time it allows them to edit it, which we'll look at further on. Or we could take them back to the customer list. Which one you pick is up to you, and it's entirely dependent on the logic that your app needs to follow. However, for the purposes of this example, we're going to redirect the user to the customer list page. So the way we do this is, instead of returning a view, we return a redirect to action. So here we're telling it it's going to divert to a different action, and we're going to tell it it's going to go to the customer list action. So the last thing we need to do is tweak our actual customer list action slightly, because as you can see here at the moment we are actually manually adding our customers in, whereas now we've got our proper add customer endpoint, we can do away with this. So we can get rid of all this code here, and just tell it to return our view with our customers, because customers is now defined right at the top of the page here, so this is accessible from all our actions. Okay, so now all the plumbing is in place, let's go ahead and actually generate our scaffolded page. Again, right click and say Add View. The template is going to be Create, and once again our model is going to be our customer. Click Add. So again, as you can see, we've got more HTML generated. You should notice a few similarities on this page. For example, again at the top we're defining our model, which is this time, because it's a singular model, it's just one model. We're setting again our page title and our header. And now notice this at using HTML.begin form. So this is another HTML method that actually spits out our form tag. As I stated earlier, it will by default set the action to the same page that we're posting from. You can actually override this in here by simply typing in what we want the action to be. But for now we'll leave as it is. Next we get this anti-forgery token. This injects a token or a random string of letters and numbers onto the page that MVC can use to make sure that the post that's being made to it is actually coming from us in the first place. This is essentially stopping people from posting from their own website to our own page, which is a common hacking technique. Next we start to construct our HTML. And again, you'll see we've got some of these label forms. Before we do, we've also got this validation summary. So the validation summary we will go into in more detail later, but basically it spits out any failed validation. So later on what we will do is we will write in code so that we can tell our model to only accept certain kinds of values, and if any of that validation changes, for example if we tell it that it's got to be a number and someone inputs a string, it would appear in this validation summary here. We've again got some similar statements to what we had earlier, so this time we've got label for, which again just spits out the text for our model name. Again that's displaying the property, but this time it's doing it in a label rather than just standard HTML text. Then we've got editor for, so what this does, it makes the MVC compiler spit out a input tag based on our model. Then we get this validation message for, which again is similar to the validation summary. When we start doing validation, it would just highlight this cell if it failed validation. You'll also notice that a lot of them have these additional items in with this HTML attributes, and this allows us to inject extra items into our generated HTML. So in this case we're going to create a class attribute, and we're going to set the class. So for example on our validation we set a class of text danger. On this one we're telling it it's going to be a control label and it's going to be 2 columns wide, and so on and so forth. As I've mentioned before, setting a class and styles in HTML is beyond the scope of this course, as it's such a big subject. But if you are interested in learning more about it, please check out my course on HTML and CSS. And finally, we basically spit out our submit button, which was very similar to what we did before, and the difference being we're actually using a class method here. So let's build our project. And again, let's right click and say View in Browser. So this is similar to the page we manually created earlier, but as you can see with the classes that the MVC has injected into our tags, it's formatted a bit better, but it essentially works in just the same way. So we can go through and create a customer, and there we go, it's taken us back to our customer list, but now we've got the customer listed there. We could go back, click create new and add another customer and create, and again it just starts to build up our list. In the next lecture we'll start looking at how we can actually create the details and the editing of our models. So now we have our lists and we can create models. The next thing we want to be able to do is to view and edit our individual customers. The process is very similar, and by now many of the generated tags are exactly the same. So let's start by adding our view page. We've already created a view customer page in an earlier lecture, so again we're going to need to delete it and start again. As before, let's go into our views and home and just delete the view customer page. Now let's go back to our home controller and go back to our view customer endpoint. Now previously we were actually posting in our customer, which is of course is not how we're going to be doing it now. This time when we're viewing a customer, all we'll be doing is sending in an ID. We'll then want to go back to some database, or in our case our in-memory cache, and retrieve the customer based on that ID. So first of all, if we delete this and delete all this, and we're going to be passing in a string of ID, and now our customer we need to retrieve from our list based on that ID. So this is standard LINQ query syntax, so we're going to use a lambda to say get the first or default customer where the ID is equal to the ID that we are passing in. Now on this page we want to do one of two things. If we have the customer, then we want to return the customer. If we don't, we need to return an error message. We could in theory just go ahead as we have now and return the customer, but if for whatever reason the customer was not found in the database, it would cause a runtime error to be failed in the application. So it's better if we can capture that and fail gracefully. So all we will do is we will check to see if our customer is of a null value. If it is, we're going to return a standard HTTP error code. However, if we do find the customer, then we want to return the view. As before, right click on the view and say add view. This time our template wants to be the details template, and again we need to select our customer class. Click add, and again we get our HTML generated, and as I said earlier, there's nothing too unexpected here. Again we have our @HTML with display for name and display for. So if you remember from the earlier lectures, display name for basically displays the name of the property, so in this case it would be name and telephone number, and then the display for actually prints out the data that's within it. Finally, again at the bottom we have some links to either edit or go back to the list. Now let's just change these, because actually to go back to our list it is the customer list endpoint, and for the next bit we're going to change this to edit customer. Save that. So let's go ahead now and create our edit customer endpoints. So the actual code is going to be very similar to the view customer, but this time we're going to add an additional edit customer view that takes in our customer and lets us edit it. Again, this is similar to what we did with our create or our add customer. So we'll have one view to return the customer and one view that lets us actually update that customer when we post it back. So the first endpoint, like our view customer, will bring in a string of ID and return the customer we want. And the second endpoint is going to take in an actual customer object. It's also going to bring in an ID. Now, strictly speaking, we wouldn't necessarily have to do this, but the syntax generated by our scaffolding, when it creates our edit customer page, actually splits out and sends in a separate ID to get the customer ID. The idea being that we will load a customer from that ID, and then we will replace the information in what we've got from the database from the posted in customer. So first thing we need to do is load the customer from the database. And again, we'll have an error trap in here. So again, if we've not found the customer, we'll return a not found error. However, if we have found the customer, we want to update the customer's name and telephone number to be that of the customer that we've posted in. And again, once we've actually edited our customer, we'd have a number of options available to us. So for example, we could return them back to the edit customer screen with a message saying that the customer details have been saved. But what I'm going to do instead is return them back to the customer list. Okay, let's build that. And again, we need to click Add View. Add View, not Go to View. This time our template needs to be Edit, and our model class is Customer. So this time our page is very, very similar, in fact all but identical to our Create Customer view. However, the difference is, rather than posting back to a Create Customer view, it's going to be posting back to the Edit Customer. Also note here this hidden field, hidden for model ID. So that's the bit where we pass back the ID of the customer that we've actually loaded. Let's go ahead and view this. Oh, one thing I need to do actually is, just like we did with the add customer, we need to add a HTTP post to the top of the action point where we're sending the customer back in, because this one is a HTTP get and this is a HTTP post, which is just the different ways that web pages can send information backwards and forwards to each other. Let's go to our customer list. So because we've stopped and restarted the compiler, it's cleared out the list, so we'll need to add in 2 customers again. Now, I've just forgot to do something there, one moment. So in our customer list, we needed to update these links here. So let's update the edit to edit customer, and the details will be view customer. And while we're here, we'll just update this to delete customer for the next lecture. Okay, let's go back in and reload this page. Now, okay, so we've got edit and view. So if we click view customer, as you can see, we get all the details of our user. We can go back to the list, or we could click edit from here. Similarly, from our list we could click edit from there. And now in the edit screen we can update some information. Click save, and it's updated our data in the back. So that's how easy it is to edit and view existing models. In the final lecture around scaffolding, we'll look at how we actually delete our models. The final task when dealing with models and data is, of course, being able to delete models. We could actually make deleting very simple. We could just pass the ID of the customer through to a controller delete action, which would then send us straight back to the customer list page. But what would be handy would be an "Are you sure" screen, and this is what our final template, the delete template, does. Because of this, we're again going to need to create two separate delete customer actions. However, because they're both going to have an input of ID, the first to get and return the customer so we can confirm it's the correct one, and the next to actually perform the deletion, will also have the ID. So the problem will be that we can't have two methods with the same signature, i.e. we can't have two methods called delete that both take an ID, because there's no way to clearly differentiate between the two actions. We could decorate one of the actions with HTTP delete, but that isn't generally enough for the Visual Studio compiler, because it would still get confused. So what we can do instead is call our method a different name. For example, we could have confirm delete, and that gets us around the compiler issues. But the problem then would be that the code that gets generated as part of our scaffolding creates this usual HTML begin form, which always sets the action to the page it's posting to, i.e. in this case it would be delete customer, trying to delete back to itself. So we've got three options. We could override the begin form method and force it to use a different endpoint, for example confirm delete, or we could manually construct our form tag and tell it to go to home/confirm delete. And both of these are perfectly valid, but the option we're going to go for is number 3, partly because it will lead us nicely into the next chapter on routing, and also partly because that's what the scaffolding is pretty much expecting to do. So let's have a look at what I mean. We're going to go back into our home controller, and we're going to create our first delete action. It's going to be very similar to our edit customer, because what we're going to do is load the customer from the database and then return them to the view with a confirm delete button. Then we need another endpoint, and this will be the one that again takes in our ID, but this time it will delete the actual customer. And this time, instead of returning the customer, we're going to say customers.delete.remove, and that will remove the customer from the list. And again, because we've deleted the customer, we could either redirect them to a customer deleted page, but again we're just going to return them back to the customer list page. So as we mentioned, we've now got an error here, which is our home controller already defines a delete customer method. So what we're going to do is change this to confirm delete customer, and then let's go ahead and generate our page. So this time the template will be delete, and again the model is customer MVC. So again, the information that gets generated is very similar to what we've done before. This is just a basic view which was identical to what we saw in the view customer. Now this time we have just a form at the bottom of the page with a submit to the delete action. And as I said, we've got begin form, which will, when it prints out the HTML, it will actually try to post it back to itself called delete customer. Again, as I mentioned, if we wanted, we could actually override this. Actually, if we wanted to override it, it would be action name followed by the controller name. So we could have confirm delete, and that is perfectly fine. But as I say, I want to show you an alternative method, which is using something called a decorator. So what we can do here is we can override the action name. So what this does is say, even though our actual action result, our C# method is called confirm delete customer, we're telling it to expect an endpoint of delete customer. So if we build and run that, again we will go before we do, let's just open the customer page actually, because no, we've got delete customer there. Yep, that's fine. So if you haven't done already, just make sure you change your action link in your customer list to delete customer. So now let's view that. Again, we'll need to create some more customers. So this time when we click delete, so we're going to delete Fred. So this is throwing up an error here. It's because even though we created our two separate endpoints, so we've got delete customer and confirm delete customer, the HTTP is still seeing two different action endpoints that it's expecting to be delete customer. So what we have to do here is, as we did earlier with our add customer, where we also add this HTTP post decorator, again that just helps differentiate from a HTTP point of view. We need to do the same thing here on our second delete action. So we need to add this second decorator there. Let's rebuild that. We'll have to add our customers back in. Now when we click delete, it will bring up the details. Are you sure you wish to delete this customer? Hit delete, and the user has disappeared from the list. So there you have it. With scaffolding, we get all the tools we need to quickly and easily create our base forms for all the basic operations you would want to do on data, listing entities or models, creating models, editing and deleting models. When we were creating our forms, we saw a number of HTML components that I said were for displaying validation errors. Just to recap your memory, if we looked at, say, the add customer, you can see we have these tags, this HTML validation summary and HTML validation message for. So in this lecture, let's have a look at how we actually use these. Luckily, using model validation is actually quite simple, and the great thing is it can be tagged directly into our models. First, we define what our validation rules are, and there are various options we can choose from. For example, we can set a minimum and maximum lengths for strings, or we could set a valid range for numbers or mark fields as required, and so on and so forth. Finally, we can also override what actually gets displayed. So for example, instead of displaying telephone, which is the name of a model, a property in our model, we could make it display enter your telephone number. Let's have a look at an example. Go into your models and open your customer model. The way we actually add validation is we use something called decorators. We need to tell our class where this validation is coming from, and so we're going to add an additional class into our project. At the top, let's go to using system.componentModel.data annotations. This external library contains the validation logic that our code will use. So let's look at an example of something that we could decorate with. So to decorate a property, again, it's like when we had our HTTP post and HTTP get and so on. We use the square brackets. And now we simply type in required. So the required property will make sure that you have to enter a value for our name. Let's also add another validation rule. Let's add a string length. Now this one's slightly different. Now we tell it what the maximum length is going to be, and if we want, we can also tell it what error message we want it to return. The other one we mentioned we could do was override the actual text that gets printed out when it's displaying the property. So instead of actually saying name, let's have it say something else. Display name, enter your name. Now we've got an error here. Let's go to the quick actions, and we need to add another using statement here, which is the component model, because this isn't actually so much a data annotation as just overriding our component model settings. We could add similar attributes or decorations to these other properties, but just to show how it gets used, we'll go ahead with what we've got there. So save that and close it down. So annotating our model on its own is not enough. The next thing we need to do is enforce the validation when our controller gets hit. Open up the home controller and find the endpoint where we actually post our customer through. So here we go, this add customer. So what we have to do is to enforce the validation at this point. We need to do it before we add it to the database. So we're going to use something called the model state, and we're going to use it wrapped in an if statement. So we're going to say if not model state dot is valid, we want to
return straight back to the view and pass through to the view our customer model that we've just posted. So what happens here is, if for whatever reason the model state isn't valid, the MVC system will capture that and it will post the form back to itself with some special headings in with the extra information in our customer object and the fact that it's not valid. That in turn will trigger our validation rules that are on our HTML page and display the appropriate errors. So let's give it a go. Let's go back to our add customer and let's view it in the browser. As we can see, enter name, so it's whereas before it was just name, it was picking up the property name. It's now picking up that extra information we put in the display name. Secondly, if we hit create now without entering any information in the enter your name part, we see that we get the validation error coming up here. Similarly, if we put a name in that's too many characters, so more than 4, and hit enter, now it comes up with the validation error saying the string is too long. And then if we pass all the validation rules, it goes ahead and creates our object. So as you can see, a very easy way to create validation within our system, but the best bit is that we get to encapsulate it all within our model itself. In this lecture, we're going to look at something called partial views. As well as normal views, we can also have these partial views, and as the name suggests, they are not a full page, but instead a snippet that can be embedded within an existing page. Partial views are often used for two main scenarios. The first is repeatable code. For example, imagine you had a menu that only wanted to display on a subset of pages rather than every page. For example, a set of admin pages. Of course, if you wanted it to appear on all the pages, you would simply put that code in the layout view. But if you want it in just a subset of pages and you don't want to have to keep repeating that code on every page, which would mean you'd have to edit the page every time you made a change to your menu or whatever it is you were displaying, then we want to embed that code instead. As always, the easiest way to explain this is with an example. So let's go ahead and create a partial view. Navigate to the Views folder, right-click the Shared folder, and click Add View. We'll give our view a name, we'll call it Submenu. And we're going to leave the template empty, but we're going to tick this box here, Create as Partial View, and then we'll click Add. We're going to do something quite simple. We're just going to add a button. And then we're going to save that file. Now let's go over to our index page. And we're going to embed that file onto our index page. We actually have two options when embedding partial views, and we'll look at the simplest one first, which is html.partial. There's actually another one called render partial as well. So the way we use it is we use @html.partial, and as I say, there's also a render partial. It actually does the same thing, but a slightly different way of doing it under the hood. In practice, however, you are better just sticking to partial.
So next we need to tell it what the name of the file is, which in our case is submenu. And we don't need the CSHTML on because the MVC system will just figure that bit out. So if we save that page and then view our index page, and now we get our bright red button. However, if we went somewhere else, for example the About page, the buttons disappeared. Also notice that we added this partial view to the shared folder. When trying to find a view, MVC will first look in the specific path. So for example, we could have put it in the home folder instead. However, it doesn't find it in the home folder. It goes and looks in the shared folder. Using shared is handy because then you can access the partial view from any other page. If you want to restrict a partial view to a particular section of the website, again for example an admin section, then maybe it would be better to keep it within the same folder. Of course, the other way we can do it as well is within the partial view there, we can actually set the entire path where it's going to be kept. However, that can very quickly start to get messy. So the rule I would advise to stick to is either the local folder if it just wants to be for a particular section, or the shared folder if we might want to use it elsewhere. When partial views are created, they get a copy of the parent view's data dictionary. However, updates made to that partial view are not sent back to the parent. Plus, given that a partial view can be rendered in many different pages, in my opinion, it's rare that you would want to try and gain access from the parent view. Sometimes, however, you do need to access data or perform some background task within a partial view. A classic example of this would be a basket link on an e-commerce site. So every time you open certain pages, you want to be able to show how many items are in your basket and maybe what the basket total is. If we tried to achieve something like this, for example, in our layout page, the problem we would have is there is no controller that the layout page directly relates to. Therefore, there's no way we can perform an action in the controller to go and return that data. So this is what we instead can use a partial view for. Again, let's see an example of doing this. We're going to create a new model. And we're going to call it Basket View Model. It's going to be quite straightforward at the moment. We're just going to have an integer to show a basket count. And we're going to have a string to show a basket total. The reason why we're using a string as opposed to, say, a decimal is so that we can statically set some formatting. Now let's go to our home controller. And we're going to enter some code that will allow us to go and get some data that will be displayed in our basket view model. So just somewhere on the page, we'll do it near the top. We're going to create a partial view result. So instead of an action result, a partial view result. And we're going to call it basket. And we're just going to perform some logic in here. So we're just going to say basket view model equals new model. And let's set some properties. Obviously, in a real-world environment, this would probably go off to a database somewhere to get this information. But for the purposes of this example, this will be fine. So the final step is we need to return a partial view and pass through to it our model. Just like we did with our other views, we can use scaffolding to create this view. So again, if we right click and say add view, we need to make sure it's ticked to create as a partial view. We could select the basket model from here, but I'm just going to leave it empty and do it by hand. So click add. And so because we've done it by hand and rather than let the scaffolding set it up for us, we just need to tell it where our model is that we're going to use. And then we're just going to create a very simple menu. We're going to use just some standard bootstrap annotation here. So again, we've got a partial view created. This time it's created it, because we did it on the home controller, it's created the view in our home folder, in our basket view there. Now let's go, we're going to add this to our layout page so that it would appear on every page, and we'll put it in here. We'll put another UL element here. So this time we're going to use the render action. Now because we're using the render action rather than at HTML like we did before, we actually have to use these brackets. We're going to say HTML dot render action. And this time, because we're linked to a controller, we need to tell it the page and the controller that we are using. So again, even though we're actually in a particular folder, because we're specifying exactly where it is, it will know where to find the view, and more importantly, which control action to run. So let's build our project, and then let's view the front page. So as you can see, we now have our basket item up in the top right hand corner. As I said, in real life these values will come from a database, but hopefully this simple demonstration can show you just how powerful partition controls can be. An important part of any web application is of course security. Security can be achieved in a myriad of different ways. The simplest is probably Windows authentication. With Windows authentication, you must have a Windows computer account on the server that runs your website. You would normally use Windows authentication if you are building an internal company intranet site, and would probably be joined to a domain, and therefore to access your web app you'd want an account on your domain. You would then be able to use the Windows or domain groups to control what access you get to different sections of your site. The beauty of Windows authentication, especially in corporate domains, is that users don't actually have to sign into the website. Provided their PC is logged into the corporate network, the client browser and web server would detect this and automatically authenticate them. All you need to do to use this mechanism is simply select Windows authentication when creating your website initially. The chances are, however, even on corporate networks, you'll want a separate sign-in for your website. Therefore, this lecture is going to cover using the ASP.NET Authorization Service. ASP.NET Authorization uses a SQL backend database. Technically, any kind of database will do, but out of the box, it will use SQL. Luckily for us, this is very easy to set up. So, let's see it in action. If you've got an old solution open, close it down. You can do that by saying go File, Close Solution, and we're going to create a new project. So we shall say File, New Project. Again, as we did before, we're going to choose the ASP.NET Web Application .NET Framework. Again, it's very important that we choose this one and not, for example, the ones in the .NET Core or .NET Standard. Let's call this one Hello Security. And click OK. So again, we get our template selector up. And in order to use security, we go to this here and we change the authentication. As we can see, by default, there's none. So if we click that button, so if we wanted to use Windows authentication, we would choose this option here, Windows authentication. But we want individual user accounts. Click OK. And provided that's now saying individual user account, click OK again. Let's build and run our site. And as before, our site looks very similar to what it did. And that's pretty much it. We've now got a fully functional site with a fully functional security mechanism. Don't believe me? Well, let's give it a whirl. First of all, we want to register an account on the system. Put in an email address. And then type in a password. Let's put password. So as you can see, it's asking us to confirm as well, and then hit register. Now, straight away we get an error. Passwords must have at least one non-letter and one or digital character. So as you can see, even right out of the box, we've got some pretty good security and authentication built in to force users to use safer passwords. So let's try this again, except this time we're going to put a password of 123 followed by an exclamation mark. And click register. And there we go. It has registered our account. It's even logged us in, and as you can see, now we are logged in, we can see our email address up here. In fact, we can even click this and it takes us to a management page where we can click through and change our password. All that is built in for you, and it comes straight out of the box with the standard template. So in the next lecture, let's have a walk through and see what it's actually done to create all this. Let's have a walk through the code that created all these pages. From our project, expand the controllers and the views folders. You'll notice that we have two more controllers than we had in our last project, an account controller and a manage controller. We also have a bunch of corresponding view folders as well. So again, we have the account folders and we have a manage folder with some pages underneath that. Most of the pages in the account and manage folders and the code in the appropriate controllers are all about providing the ability for users to register, log in, reset passwords, and so on, as we have just seen. They also allow us to set up features such as two-factor authentication, i.e. sending text messages to a phone in order to complement your password, or for setting up Facebook, Google and Twitter authentication, i.e. having the ability to make your application authenticate against one of these accounts. As you can see, there's a lot included and it would be a lot to go through. So let's just go through some of the basic features such as the registration and login. Open the account controller and let's have a look through. The first thing we'll notice is at the top of the page we have this authorize decorator. This decorator tells MVC that a user must be authenticated in order to access any of the pages within this controller, with the one exception that we'll see in a moment.
This is important because without that decorator, the pages on the controller wouldn't be secure. So you have to remember that when you want to secure your pages, you have to add the authorized decorator to either the top of the class itself or indeed against the individual endpoints. Also note at the top of the page we have these two items here. We have an application sign-in manager and an application user manager. And again, these get injected into the controller itself, into its constructor. This is similar to when we do the same thing with interfaces. But again, all this is doing is the built-in ASP.NET authentication system, hooking up everything that we need in order to use authentication. You can probably guess that the sign-in manager is used for controlling sign-in and the user manager used for controlling users themselves. Scroll down the page and we'll see two login results. So we've got a login action result that takes in a string of return URL, and then a second one which has been decorated with HTTP post, and it takes in a login view model in a return URL. The return URL is so that if a user hits a particular page on the website and is bounced to log in, it captures the URL they were trying to access to pass through the login mechanism, so that once they have logged in, we can redirect them back to that return URL. Also notice that these both have an allow anonymous decorator. So this is basically overriding the authorized attribute decorator to say, well, actually, if you hit these pages, you don't need to be logged in, which makes sense because these are the pages to allow us to log on. So the first page is just the one that returns the view with our request to enter our username and password. The second one is the code that actually performs the login. This action, as we said, takes in a login view model, and if we look at the login view model, we can see it takes in an email, a password and a boolean to remember me. And the first thing it does is checks that the model state is valid. If there's anything wrong with the model state, so for example if the two passwords didn't match up, it would return the view back with the errors embedded in them and display them appropriately. Again, this is very similar to the model validation pages that we saw earlier. So next, if the model is valid, it uses the sign-in manager to sign in, and it does this by passing in the email, the password and the boolean to say whether it should remember the user. It also sets a default to tell it whether we should lock out on failed password attempts. The result of that is passed to a result variable, and in this code here we perform a switch to check on what the result of that is. So if it's a success, it will return us back to the return URL that we were trying to access. If the account has been locked out, it will take us to a lockout page. If we've enabled additional verification, again it will take us to the appropriate page. And finally, if it's any other result, it will take us to back to our own page, but with an additional error saying the login attempt was invalid. If we just go back to the view model, we can see again, as we've mentioned, that these decorators will set the validation results. So as you can see, we are saying that they are required. We're setting the data types, so this one needs to be a password, and this one is a validation that will perform automatic checks to make sure it's a valid email address. So even though we've got some basic rules on here, such as to say whether a field is required and that something's an email address, you might have noticed that it's not covered all the rules. For example, if we didn't enter a password that's complex enough, it comes back to tell us that. So where are these things set? If we scroll up and look into our App Start folder, we will see this identity config file. Let's open this up. And the identity config is where we set some of these additional options. Again, it's all boilerplate code that is basically just there to hook up our ASP.NET identity service. If we scroll down to this create method here, we will see where we set our different validators. So for example, we are setting a minimum password length of 6. We're telling it that we have to require a non-letter or digit, require a digit, require lowercase, require uppercase. So again, if you want to restrict your password length to even longer passwords, or if you want to de-restrict some of the requirements and set these to false, here's where you would do it. Modifying some of the basic settings is quite straightforward. As I also mentioned, there is quite a lot of different services and things that you can use in here, but on the whole, because the account management just generally works, it's very rare you would need to actually modify any of those. However, if you did want to modify anything, or if you wanted to extend some of the information that maybe you capture as part of the user, we can do that by actually extending those basic attributes. And in the next lecture, we'll show you how to do that. There are times when you want to store more information than the standard user in ASP.NET Security allows. So how do we get around this? Before we look at the how, let's discuss the options first, and why you might want to choose one option over the other. A typical smart scenario might be that users are actually customers, i.e. you are building an e-commerce site, and when your customers register, they want to create an account and you need to capture additional information such as their address. So option 1 would be to extend the user account itself with the additional information such as the address and maybe a telephone number. And this is what we'll do during this lecture. But before we do, let's examine the alternative. Although, as we will soon see, we can add these extra attributes, it's important to understand that where possible, a model should encapsulate particular usage. In development terms, this is the single responsibility principle. The idea is that a model, in this case a user, should only be responsible for managing a user's ability to sign into your website. This is technically different from managing a customer. For a user, you need to store their username, password, and perhaps what access rights they might have. For a customer, we might want a manager in order to manage what orders they have placed and what their shipping details are. For this reason, you would normally want to keep the two records separate. Apart from anything else, having the data in separate tables can help you to keep the details more secure in the event that your site gets hacked. So what I would normally do is when a user registers is create two separate records. I would use the built-in mechanism for registering the normal user account, and then I would create a separate customer record in a separate table, but link the two together on the user ID. But let's pretend you're going to ignore me anyway and store the user's address in the user record. So the first thing to understand is where the application user is stored. Go into the models folder and have a look at the identity model file. So the application user is what our user model actually is, and we can see that it actually implements identity user. If we right click identity user and say go to definition, we can see that it implements a particular subset of identity user that has these particular setup. So for example, identity user login and so on and so forth. So let's follow this down the chain. Let's right click this second identity user here and go to definition. And now we can see some more information here. So for example, we can see we are storing an email confirmed, a password hash, a security stamp, phone number, and so on. However, because this is part of the ASP.NET security mechanism, as we can see up here, it's part of the Identity Entity Framework library, we cannot modify this directly. The other thing to understand is how the ASP.NET Identity System knows where to store that code, i.e. where the database is. And we can find that within the web.config of the website. So you can see here when we install our basic ASP.NET security site, it creates this connection string section in our web.config and adds this default connection. By default, it creates this rather convoluted connection string. So we can see it's going to localDB /MSSQL localDB. So this is a special kind of SQL database called localDB, which we will go into more detail later on. Next, we tell it to attach a database file name and what the file name is. Basically, it's based on the name of our application, prefixed with ASP.NET, and then given a random time string afterwards. And then it gives us an initial catalogue, which is again pretty much the same as the file name, and this would be the name of our actual database. Because we've already run this system, the ASP.NET security mechanism automatically created that database for us based on this connection string. And in fact, we can go and have a look at that. Rather than use the SQL management tools, we're going to use a built-in version of SQL Manager, which is a cut-down version that's built into Visual Studio. Go to View and Server Explorer, SQL Server Object Explorer, and we can see here our SQL Server with the connection string that it's with the database as defined in our connection string. If we expand that and go to database, we can see here our actual database. And if we expand that, we can then start to drill down and look at the actual tables. If we right click ASP.NET users, we can actually go down and say view data. So this will open our table, and as we can see here, our user account that we created when we registered. If we expand these, you might notice that, in fact, actually, if we looked at this side, we can look at the columns, which is an easy view. You may notice that we don't actually have a password field, but we do have this password hash field. And if we're looking there, that looks absolutely nothing like the password I entered. That's because by default we don't store the passwords directly. The mechanism encrypts them first and stores the encrypted hashed result. This is of course far safer and protects your users in the event you are hacked. As mentioned, the database gets created on first use. Because of this, if we want to try and update our user model now and then register new users, it will complain because the model and database are out of sync, i.e. our model will contain more fields than our database table. There are options to update this, but for now we're going to go an easy route. We're just going to delete the database. So right click the database and click delete. Sometimes it's handy to click the Close Connections button in case there's something still running in the background, and click OK. So now we've cleared that down, let's go in and we want to edit our identity user. If we go into our identity model class within the models folder, what we can actually do is add additional items at the top here. So for example, we could have a public string
So by adding these up here within our application user class, it will extend that table and our model with these additional attributes. So that will update the table, but when we actually register a user, it uses a register view model, so we need to go and update that as well. Go into our account view model class and find the register view model. Here we go. So as we saw earlier, by default we just store an email, a password and a confirm password. So again, we need to add in these 2 extra fields. What I will actually do is just copy and paste these. And let's also add a required decoration to each. Next, close those down and we need to go into our account controller. And we need to update the registration method to copy across these additional fields from our view model to our actual database model. So we need to find the register action. And where we have this setting here where we say our new application user, let's just put these onto additional lines so it's easy to see. Put a comma after there, and then if we press space we get to see all our properties for the application user, and here's our new ones. So we set them to our model.firstname because the model is the register view model. Then we can save that, and then the last thing we need to do is go into our actual view. So again we want to go into the account folder in the views and we want to find the register page. So again this is very similar to the scaffolded forms we were creating earlier, and what we want to do here is add our first and last name fields. So let's just copy what we have there and we'll change this to first name. And then we're ready to go. So just to recap, we have extended our identity model by adding the additional fields. So the identity application user in the identity model is what gets stored in our database. We've updated the register view model, which is the view model we use to capture the data off the user. We've updated the account controller on the register method to assign the additional 2 fields between the view model and the database model, and then we updated the register page itself. So let's start that running and see what happens. So now we get our additional fields here. And hit register. Now let's close that page down, stop the debugger, and again let's go to our SQL Object Explorer. What we'll need to do here is click this refresh button just to make it rescan for the databases. So our database has reappeared. If we look in our tables view at our ASP.NET users, we can see now we have our first and last name columns, and if we view the data, we can see these additional columns have now been added with the additional information. So as you can see, it's the ASP.NET security system that's built into ASP.NET is not only extremely powerful, it's also incredibly easy to extend.